needs of farmers and consumers. With GMOs, the future holds sustainable production of nutritious food, better tasting, and increased protection of plants from diseases caused by climate change.
You might not know this, but every day you eat the fruits of plant breeding. In fact, much of what we eat would not exist without it. Plant breeding started many thousands of years ago, when our ancestors first started farming. By selecting the best plants and breeding them over time, ancient farmers cultivated crops that were tastier, more nutritious and stronger. A 19th century Austrian monk Gregor Mendel began to discover how plant characteristics were passed from one generation to the next. This laid the foundation for a modern understanding of plant genetics. As the years went by, plant breeders' understanding of agriculture continued to progress. In the 20th century, we made incredible breakthroughs in understanding the mechanics of genetics, DNA, the genetic code, and how to read whole genomes. Each of these have increased our ability of breeding better crops. Today, our understanding of how to harness plant breeding continues to progress, but we also face new challenges like the global spread of plant diseases and pests, dwindling natural resources, climate change, and skyrocketing population growth. Helping farmers keep pace with these challenges in a safe and sustainable way continues to be the goal of plant breeders. Thanks to our understanding of genetics, we now know how plant breeding works at the level of genes. When scientists combine genes from two related plants, their offspring have mixed characteristics from both parents, but plant scientists have to selectively breed plants for many generations to have one desired characteristic, a process that takes years. Now, innovative gene editing techniques allow plant scientists to use DNA information from the plant's family to directly add, delete or replace specific genetic information using its own biological processes. Just like traditional plant breeding, but with greater precision and efficiency that we have come to expect in modern times. Throughout history, consumer and farmer needs have been answered using innovation and science. What could the future hold? More sustainable food production, better tasting and more nutritious produce, increased protection of plants from drought and diseases, adapting the basic principles that have been used for generations in a precise manner. Today's evolving plant breeding methods are preparing us to face 21st century challenges.
Understanding GMOs. Ever since man first planted crops for food, he has been selecting for better yielding crops. Then he learned to cross crops with desirable quality to get seed with better features from both parents. The plant from first cross has all the traits of its parents and is bred to remove the undesirable ones. This takes many years. In GM technology, we can take gene from any species of plant or bacteria and insert it into the genome of the crop, such that it becomes part of its inherited traits. This is a precise change in single generation to get the plant with desired trait. Commonly used GM crops are pest resistant. Similarly, we can improve crops for yield, less fertilizer use, drought resistant, etc. to help farmers fight these challenges in safe and sustainable way. The GM crops undergo extensive testing before being cultivated, making them safe and most well studied. GM plants are safe for planting, processing, and consumption like non-GM plants. Throughout history, science has answered the needs of farmers and consumers. With GMOs, the future holds sustainable production of nutritious food, better tasting, and increased protection of plants from diseases caused by climate change.
You might not know this, but every day you eat the fruits of plant breeding. In fact, much of what we eat would not exist without it. Plant breeding started many thousands of years ago, when our ancestors first started farming. By selecting the best plants and breeding them over time, ancient farmers cultivated crops that were tastier, more nutritious and stronger. A 19th century Austrian monk Gregor Mendel began to discover how plant characteristics were passed from one generation to the next. This laid the foundation for a modern understanding of plant genetics. As the years went by, plant breeders' understanding of agriculture continued to progress. In the 20th century, we made incredible breakthroughs in understanding the mechanics of genetics, DNA.
Good morning to one and all, and good evening to our speakers from the US. It is my privilege to welcome the dignitaries of the day, the dynamic and ever-encouraging and beloved Vice-Chancellor of UASB, Dr. S. Rajendra Prasad, the Director, Department of Agriculture, Government of Karnataka, Dr. B.Y. Srinivas, Director General of the Federation of Seed Industry of India, Mr. Ram Kaundinya, Dr. P.H. Ramanjani Gowda, Honorable Board Member and former HOD, Department of Plant Biotechnology, University of Agricultural Sciences, Bangalore, and eminent biotechnologist, Dr. Sandhya Agarwal, Dr. Ratna, and the team, and their team from the Alliance for Agri-Innovation. A word of welcome to the speakers of the day, Dr. Perrott, Member, Institute of Plant Breeding, Genetics and Genomics, University of Georgia, Athens, USA, Dr. C.S. Prakash, Dean, College of Arts and Science, and Professor, Plant Genetics, Genomics and Biotechnology, College of Agricultural, Environmental and Nutrition Sciences, Tuskegee University, Tuskegee, USA, Dr. Vibha Ahuja, Chief General Manager, Biotech Consortium of India Limited, New Delhi, and Dr. Sr Rao, Advisor, DBT, Government of India, key officers of the university, the Director of Research, Dr. H. Achari, Dean Agri, Dr. D.L. Savitrama, Dean PGS, Dr. Srinivas, and all other key officers of the university. Officers of the Department of Agriculture, farmers, faculty, and students of USD and all other universities, and all participants to this virtual international conference on current scenario and path forward for GM crops in India, organized by the University of Agricultural Sciences, Bangalore, Federation of Seed Industry of India, and Alliance for Agri-Innovation. I am sure this will be a wonderful program for all of us to learn, discuss, and enhance our knowledge about GM crops, their uses, advantages, and challenges of acceptance in India and outside India, and understand the way forward for adapting this amazing technology for the benefit of humankind. I now call upon our Dean Agri, Dr. D.L. Savitrama, for the inaugural address. Please, ma'am.
Thank you very much, Anita. Respected dignitaries and the speakers and all the people who are on this platform and the audience who are faculty, students, Department of Agriculture people, Dr. Srinivas, and everyone. So food and agriculture lies at the heart of 2030 agenda of Food and Agriculture Organization, from ending poverty and hunger to responding to climate change and sustaining our natural resources. To be sustainable, agriculture must meet the needs of present and future generations while ensuring profitability, environmental health, and social and economic equity. This presents a massive challenge to agriculture. How do we feed all these people with nutritious food in a sustainable way? Presently, the yields of major crops are stagnating, while the demand for food, both grain and animal protein, is growing. To meet the challenge of improving yields requires a constant commitment to generating a steady supply of improved cultivars and lines for all major crops. Of course, conventional breeding is doing very well, but it is not just sufficient to meet the targets. Biotechnology and the production of genetically modified crops and latest technology like clustered regulatory interspaced short palindromic sequences or CRISPRs edited crop plants can fill this gap. The commercial development of GM crops began in 1996 with GM corn and has expanded every year with the cultivation of GM crops. According to the International Service for the Acquisition of Agri-Biotech Application, in 2018, the 22nd year of commercialization of biotech crops, 191.7 million hectares of biotech crops were planted by up to 17 million farmers in 26 countries. From the initial planting of 1.7 million hectares in 1996, when the first biotech crop was commercialized, the 191.7 million hectares planted in 2018 indicates 113-fold increase. Thus, biotech crops are considered as the fastest adopted crop technology in the history of modern agriculture. So, today's program is current scenario and path forward for GM crops in India. So, this is a program which has been organized to make people aware of the importance of GM crops, and this to make decisions on the acceptance of GM crops by both farmers and consumers. Many awareness programs can be created by setting up public consultations across the country in local languages with active participation from the representative groups of farmer organizations, that is, scientists, both public and private sectors, NGOs, agricultural experts, consumer groups, citizens forum, government officials, media, seed suppliers, traders, doctors, and lawyers to negate the negative perceptions and reluctance towards GM crops and foods. Add to this, advertisements in local media prior to the commencement of the event can ensure proactive participation from various groups. With these remarks, I am delighted to not exactly inaugurate, I just say inaugurate this virtual international conference on current scenario and path forward for GM crops in India, organized by University of Agriculture Sciences, Bangalore, Federation of Seed Industry of India, and Alliance for Agri-Innovation. I welcome all the dignitaries and speakers and wish this event a grand success. And our Vice Chancellor will join in sometimes in join, and he will also be speaking on this.
Yes, joined. Yeah.
Sir, I'm sorry, I spoke a little bit. You can join this and please continue.
Thank you, madam.
Yeah.
Yeah. Good morning to all of you, the respected speakers, and my colleague Dr. Savitrama, all the officers and the organizers. And also I could see very surprisingly Director of Agriculture, Dr. Sr Rao is there. And the important speakers I could see Dr. Prakasa, good morning to you, and Dr. Oine Parji, then Vibha ma'am, and also Dr. Rao. Once again, good morning, and thank you for accepting our invitations and be a part of this program. I would like to congratulate all the organizations, US Bangalore, and also the Federation of the Seed Industry of India, and also Alliance for the Agri Innovation, for organizing this important event, which is need of the hour. As we all aware, today there are some questions arises. Those questions are, are the GM crops important? Are they needed? Are they, have any safe? And why? Who will be getting the benefit? These are all the questions triggering us. Yes, as and today, the crops, GM crops, have benefited India and the world tremendously. At the same time, there is not a single proven, evidence of any ill effects of these biotech crops for the human or the health, animal health. So this is the one. But if you look at the total, the progress what we have with respect to the food security, It has improved worldwide over the past, few years, but still the hunger and the food insecurity persist. In the past, we used to battle, see, because increasing the populations and our natural resources and other things, which is, a threat for us. But still, what is the alternative? In one of the meeting called by the earlier DG during when we have reached the Green Revolution 50 years, so at the time, there was a question, what should be the next option for the next Green Revolution? So amongst many people who have mentioned, one of the option is the hybrid technology. The second option was the GM crops. These are all the areas which need to be addressed in order to achieve the second green revolutions. And also the storage losses to be minimized. These are all the options. That means the GM, crops introductions and working in this direction is nearly need of the hour. If you look at the total, the food productions, the last few years, 311.8 million tons of food in the last 15 years by this, biotechnology alone in the world. So this is clearly speaks, yes, we need to. Then much debate has been made on this. In fact, our university also organized many events involving the farmers and also the other stakeholders like industries and also the scientists from the different parts, the sectors to create awareness. So this was the program which we have really made. If you look at the scenario in the India, you see the good example is the BT cotton, where we are, almost 95% of the area is under BT. So that speaks there is, the favor for the crops, such BT, that's, kind of GM crops. If you look at the today, with respect to the oilseed crops, so we have the major soybean and the groundnut. Next important is a mustard crop. So here it is, we are working conventional breedings, everything. The yields are almost stagnated, and we need to go for the other techniques or the tools by which we need to improve the potential also oil content. Today, the India needs about 21 million tons per year the oil requirements. But today we are producing around 6 to 6 million ton. But what we need, so we are spending a lot of almost $10 billion US for the import of the oils in the country. So therefore, this is the area. Almost some work has been done from the Delhi University. So many work has been done, but only we need to policy how it should be taken it forward. Again, with respect to the pesticides, India alone, so we are, there is an evident 236 kilo of pesticides are being used every year in India. So how to cut down and curtail, because it is not only costing, but also it is costing the environment. That needs to be, the one of the area that we are thinking. Then comes to the biosafety. Of course, the several international organizations like, World Health Organization, Food and Agriculture Organizations, and OECD, that is Organization for Economic Cooperation and Development, recently confirmed there is a biosafety. Whatever the things which are doing, it is safe and it can be used. So these are all the kind of the things which need to be taken, enlighten the farmers or the end users, so to promote this technology. My last this one is how these GM crops really have an implication on the environment. So these point has to be deliberated, and we'll convince our farmers or maybe the end users. So can we take it these GM crops as one of the this one, because now we are getting a lot of tools like CRISPR-Cas, so many things is coming. So in that directions, I feel this program, what we have planned to this event, the current scenario and the path forwards for the GM crops in India. Of course, there are well learned and the scientists who are worked in this line are there. So I first of all thank them, and I wish this program is going to give us a lot of inputs to take it further forward in terms of research, in terms of convincing the farmers, in terms of suggesting some of the policy issues to the government. With this, thank you once again. and all the best. I hope this program will be a grand success. This is my thing. Thank you so much.
Thank you, sir.
Over to Madam.
Thank you, sir. Dr. B.Y. Srinivas, the Director, Department of Agriculture, Government of Karnataka, will now express his views for the inaugural. Please, sir.
A very good morning to all the dignitaries. Dr. Rajendra Prasad ji, Prasad sir, Dr. Savitrama madam, Dr. Anita Peter ji, US scientists, and all department officers. I am very happy to participate in this webinar on current scenario and path forward for GM crops in India. There is been a lot of misconception on GM crops. I hope this webinar gives us a platform to discuss on various positive on application of GM crops on our farmers field level. I wish all the best. Thank you. Thank you, madam.
Thank you, sir. The Director General of the Federation of Seed Industry of India, Mr. Ram Kaundanya, will now address us. Please, sir.
Thank you. Thank you, madam, and thanks everyone. On behalf of FSII, I welcome all of you to this important seminar on GM crops. We look forward to a rich discussion and showing a path forward for the GM technology, which has been caught in a difficult situation for the last 1 decade. If you see, since 2005, there has been no fresh approval of GM crops in India. The current regulatory stalemate has resulted out of the moratorium on BT Brinjal in 2010 and GM mustard on the hold since 2017, and both were held back at the political level, not at the scientific level or at the regulatory level, but at the political level. Questions are raised about the safety, regulatory process, seed sovereignty, and many imaginary problems by various people connected and unconnected with agriculture. Activism and lack of political consensus has led to stalemate. But fortunately, farmers have been very positive and they have been asking for this technology, as is evident from their demand for BT Brinjal, HT cotton, and various other technologies, which will be very critical for their success and for their competitiveness in the international markets. HT cotton is stuck due to regulatory hurdles and ideological oppositions from some sections of the society. Adverse policy environment, the regulatory application is withdrawn because of all these factors. But again, fortunately, the farmers want it. That means there is a ground level demand for this type of technology. Some states don't allow field trials, which speaks of lack of coordination and alignment between the center and the states. Fortunately, Karnataka has been allowing for the last few years, and we hope that trend will continue. But if you see, on the other hand, the country needs the technology. In my opinion, and in our opinion, we should not look at all GM as with a broad brush. We should look at them in terms of each trait and understand which crops and which traits are needed for India. If you look at this decade and beyond, what are those critical items that we need? Like the Vice Chancellor, Dr. Rajendra Prasad mentioned, oil seeds will be a very important area where we can apply this technology. But about 5 traits I would like to mention. One is weed management. Labor costs have gone up. If you see Government of India's own data, 50 to 60% of cost of cultivation today is labor cost. And this is going to increase, it will not come down. So there are technologies which can save labor costs, and with better weed management, we should look at them. Number 2 is drought tolerance. We all know that water will be a problem. Climate change is on us, temperature and drought will be there. So we have technologies which can handle them. Third is fertilizer use efficiency. We are all aware that Government of India spends 80,000 crores every year on fertilizer subsidy. and fertilizers in turn have damaged the soil. So there is an urgent need to reduce fertilizer usage, and technology can help us there. Insect pest control, especially new pests which are coming like fall armyworm on corn and things like that. So we should look at using technology control to control such invasive pests. And fifth is the nutrition. We all understand very clearly that the next decade belongs to nutritional security, achieving nutritional security for the country. I think these are 5 areas where I feel that we should look at using the technology without any inhibition, without any scare, and without any hesitation. Industry, public institutions have invested large sums of money in the development of this technology in the last 20-25 years. DBT itself has spent thousands of crores of money on this, and private industry has invested. Some of them have scaled back on the work and investments. Some of them have completely stopped and withdrawn. So I think it is time for the scientists and the regulators to speak up. If the scientists don't speak about the technology that they are working upon, it is very difficult for the industry to defend it, because industry is always seen as an interested party. So I think it is very important that the scientists speak up, the regulators speak up for themselves, because many activists have been downgrading and they have been ridiculing the regulators. So I think it is also a very sad state of affairs that the regulators' assessments are not trusted by either the activists or even some parts of the government. So I think the investors, what do they want? Investors like the private industry and even the public units, they are looking for a stable, supportive and progressive policy environment and political alignment between center and states and among all political parties. If we can achieve that, I think that is something on which we must all work together. In addition to what we may discuss today, and in addition to many scientific facts which are available, scientifically this was never under a dispute. That the effectiveness of this technology, the safety of this technology, and the usefulness of this technology is amply demonstrated in India and all over the world. But I think what is needed is a work to convince some of those who are continuously opposed and how to work on clearing the way for the technology. Thank you very much.
Thank you, sir. Thank you. A word of thank you to Dr. T.L. Savitrama, Dean Agri, Dr. S. Rajendra Prasad, our beloved Vice Chancellor, Dr. Srinivas, the Director of Agriculture, and Mr. Ram Kaundinya for their valuable inputs during the inaugural session. And now we will go on to the talks. It is my pleasure to introduce the first speaker of the day, Dr. Wayne Allen Barrett, Program Director, Integrated Plant Science, Institute of Plant Breeding, Genetics and Genomics, University of Georgia, Athens, USA. He is a professor of crop sciences in the University of Georgia's College of Agricultural and Environmental Sciences in Athens. Since 2017, he has been an elected fellow of the American Association for the Advancement of Science. His group conducts research on the development and use of technology for crop genetic engineering and genome editing. The lab members also use molecular markers as a tool for transgene development, work in gene discovery, and study insect resistance. An outspoken advocate of biotechnology, he has been advocating genetically modified crops. I request Dr. Barrett to kindly enlighten the participants with your valuable thoughts on how CRISPR plants are regulated throughout the world. Please, sir.
Okay, so thank you so much for that introduction, and good morning to everybody. It's been a very cold and rainy winter day here, so I'm kind of envious of anyone in warmer weather right now. So CRISPR is a catchy term that you hear in the news, but it's actually only one of the many ways in which we can edit plants. So I'm really going to talk more about editing in general. And regulations are not a fun topic to talk about, so I want to give a little bit of background on what they are and why they are or they are not regulated the way they are. But it's an understatement for me to say that here in the U.S. we are really excited about editing and what we can do with it. And sort of to describe what it does compared with engineering, I stole this from somebody else. This is not my original words, but when we were doing transgenics, we're bringing talent in from the outside. You know, you don't have it, so we're going to bring in the gene for you. Whereas with genome editing is we're going to bring out the best in you. So it's more of a work with the materials that we have to make them better. I want to make it very clear that genome editing is not a substitute for GMO. Rather, it is a complement for GMO, and I view both technologies as extremely necessary. They're very complementary, and they're both necessary. If anything, I think genome editing is more likely to replace some of the traditional breeding techniques than it is to replace GMOs. So here in the U.S., we already have the first edited product on the market. It is a high oleic soybean oil. It's sold under the brand Calino, and it is by a company called Calyx. So normally soybean, the soybean seed is going to make it's easier to see. The soybean seed is going to make oleic acid. There's an enzyme that will convert it to linoleic acid and to linolenic acid. And this is what will turn rancid. And it doesn't have very good cooking temperatures. So what they did is they used editing to remove the enzyme that makes this conversion, which means linoleic, linolenic acid are not made. And it's high quality oleic acid. So it's, if you can imagine olive oil, the quality of olive oil, but at the price of soybean oil. But there are many other things that are coming down the way. This is work that a colleague of mine at the University of Kansas has done. It turns out that plants have genes in them that limit the size of the seed. So this is normal bred wheat, the wheat that we grow around the world. Here they used editing to remove 2 genes, and notice the difference in the size of the seeds. They removed 2 more, and again, you can see the difference in the size of the seeds. And they removed 2 more, and again, you can see the difference in the size of the seeds. This is a colleague of mine at Cold Spring Harbor trying to just adapt the way plants grow so they're easier to grow in urban areas. This is the tomato, the normal tomato that we all know, with 1 gene edited, 2 genes edited, and 3 genes edited. This is actually work out of China that I really like. Here they were editing abscisic acid receptors in rice. This is what the rice looks like normally. It's the way rice normally grows. If they remove, I think, 8 receptors, it looks like this. If they only remove 2 receptors, it looks like this, 3 receptors, and so forth. And the winner was this one here, where they remove 3 receptors. And then in the field, they're getting a yield increase between 25 and 30%, which is really an enormous gain for simply changing 3 genes that were already there. This is work that I'm doing in my laboratory. We're working on bioenergy grasses. And we have this set of genes that are involved with the cell wall synthesis. There's 4 genes, and the plant's diploid, so every gene is present in 2 copies, which means there's 8 alleles to remove. There's a second set of genes that is present in this group has 8 copies of the same gene, each one present twice. So that's 16 alleles that we need to remove. And when we remove, we're actually able to remove all 8 alleles at one time of this group of genes, and the plants just double in size when we do that. And in this second group of genes, we have actually removed 10 out of the 16 alleles. And when we do that, we get an even larger increase in biomass and commensurate increase in bioethanol out of this. So we're really excited about this as well. If one goes to the USDA website where people are asking the USDA if their products are going to be regulated or not, the answer is no, they're not going to be regulated. One sort of can get an idea of the type of research that's going on using genome editing. There's people have asked about avocado that does not turn brown, peas with better taste, better oil than canola, low phytate in canola, fungus resistance canola, barley that's better for beer, strawberry plants that bloom all season, tomato that's better for mechanized harvest, virus resistant tomato, non-browning lettuce, drought tolerant maize, high yielding maize, fungus resistant maize. You get the idea, canker resistant citrus, high yield potatoes, non-browning potatoes, novel color petunia, nematode resistant soybean, and so forth. So this technology has just unleashed a whole lot of traits that are making them much easier to work with, and different people are working on them. So I mentioned at the beginning that CRISPR is just one of many genome editing technologies that many times we just call them new breeding techniques or new breeding innovations. But some of these have been around a really long time. For decades, really, we've been able to use meganucleases or oligonucleotide-directed mutagenesis. But these technologies were really cumbersome. They were very cumbersome, and they never gained a lot of use. It wasn't until zinc finger nucleases were just really invented that editing became a lot more practical. And it set off this race that was really amazing, because about 6 months after zinc fingers came out, talons came out, and they were even easier to use than zinc fingers. And about 6 months after talons came out, CRISPR-Cas came out. And CRISPR-Cas really is the lowest cost of this. It is the simplest one to implement. It's the most versatile. It's the one that you can really get the most use out of. And that's why you hear so much about CRISPR-Cas. So this whole technology is called editing because it is very much like editing text. And when you're typing your words, you can go back, change, delete words, add words, change words, and so forth. So that's what we call editing. And I want to review the types of editing that are possible because it really does affect regulation. So to begin with, we can delete text. And in the example I gave you where we have eat more fresh vegetables, I can go in, I can delete fresh and just say eat more vegetables. This ability to remove the function of genes is called SDN1 for site-directed nuclease type 1. and it is a state of the art. Almost all the editing that you read about right now is SDN1. And it's really like natural or induced mutation. So the real gain of SDN1 is that it's going to replace mutation breeding, or at least complement mutation breeding. According to the FAO and the International Atomic Energy Agency database, there's over 3,000 known varieties that have been developed from mutation breeding, either radiation or chemicals. This would be an example of a facility in Japan where there's a source of cobalt-60 in the middle and it's irradiating crops. And there's whole manuals on how to do mutation breeding and things that you would be familiar with. And, I think these are now all over the world, the seedless pink grapefruits and all the pasta wheats, a lot of rice varieties and so forth. So mutated varieties have a very long history of safe use, both as a food source and in the environment. Second thing that we can do with editing is we can overwrite text. So, for example, in the United States, we might say eat more canned vegetables, whereas in England, they might say eat more tinned vegetables. So editing gives us a way to correct the word and change a little bit of it so that instead of saying canned, it says tinned. And this technology is still not commonplace, but it should be replacing backcross breeding. For those not familiar, this is the cultivated soybean. And here where I live, all the soybean used to suffer from a disease that you can see here. It's a fungus, and the disease is called frog eye leaf spot. So our breeder went to the soybean germplasm bank and looked at about 17,000 different varieties of soybean, and he found one that was resistant. The issue then is, the problem is it was not in a cultivated soybean, but rather a wild soybean. And as you can see here, the wild soybean does not look at all like anything that a farmer would plant. So the challenge is, how would you move the resistance gene to replace the susceptible gene? So he planted them in the field. Here you can see the wild one and the cultivated one. He crossed them. When he crossed them, he got something that looked halfway between these. So he took that and crossed it back to the domestic one. And he took that plant and crossed it back to the cultivated one. And he took that one and crossed it back and crossed it back and crossed it back until finally he had something that was worthy of being cultivated in a field, but was resistant. And this process then, it's about one cross a year plus time for seed increase. It was about 10, 12 years that it took him to do that. With CRISPR, instead of taking this many years, we could do it in 6 months. So it's a huge, we can imagine the huge time savings in doing this. So finally, we have, again, just like you can always insert words with editing. In this case, I've got, instead of saying eat more vegetables, I can say eat more fresh vegetables. And we call this 3. So to recap, we can do 1, which is removing traits, deleting genes. We can do 2, which is sort of overriding them or correcting the gene to change its properties. And 3, we can add a gene altogether. And when we do an SDN3, it is still a GMO, I think, all over the world, pretty much. So the regulations. Latin America actually led material biotechnology. So if you stop and think, when you're removing text, we're not adding anything, so there's no novel combination. If we're editing, if we're changing a gene to look like a gene that's already in a wild soybean, there is no novel combination of genetic material because we can do it with breeding. So in most of Latin America, SDN1 is exempt from regulation. And some SDN2 and SDN3 might be exempt as well, depending on whether they contain a novel combination of genetic material made with modern biotechnology. You do have to, this assumes that any transgenes have been removed, of course. And I think this will be true in all parts of the world. And government, you do have to show your plant and your data to the government so they can verify that there's no transgenes in there. And at that point, your edited plant becomes exactly like a plant that would have come out of a mutagenesis program. You can plant it freely, you can grow it freely, you can cross it freely. There's just no restrictions. Australia, they've excluded SDN1 from their regulations. And they use a different criterion on how they decided to do that. Their criterion is whether a template is used as part of the editing. So to explain that a little bit more, when we do SDN1, what the CRISPR, it's actually the Cas does all the work. CRISPR gets the credit, but Cas is what does all the work. Cas is going to cut your DNA, and then the same way that, say, a gamma ray would cut the DNA. And then when it gets repaired, it's going to leave a scar behind that's going to keep the gene from working. But there's no additional DNA added. When we're doing SDN2, you have to put a copy of the correct sequence in there. So that when the plant repairs this cut, it knows what to put in that gap. In SDN3, where we're inserting a whole lot of genes, again, the DNA to be inserted has to be added there. So when the plant will repair the DNA by copying what's here, but the DNA itself that we add is not going to remain behind. I have always had trouble between these two because they are really two ends of a continuum, so it is sort of a gray area where SDN2 stops and where SDN3 starts. But regardless, Australia says this is okay, but this is not. In Canada, the regulations are still under review. They just had a meeting about a month ago where they were convening panels of experts to get various inputs. But in general, as a rule of thumb, as we say here, Canada operates on what they call a novel foods criterion. And has this food or this particular genotype been part of our environment and part of our food supply? They do not care how you make it. If it's something different from what's been there before, it does not matter if it was done with conventional or biotech. They will want to look at it. It's the most scientifically defensible of all the regimes out there. The United States is sort of a bizarre one. And part of it is that the United States never enacted any new laws to regulate biotechnology. Instead, they took laws that were written, some of them as early as the 1930s, and adapted them to cover biotechnology. And so they came up with what they call the Coordinated Framework for Biotechnology Regulation. And in it, the USDA it can declare a plant to be a pest. And by declaring a plant to be a pest, it can regulate it. FDA can regulate anything that's going to be used for food or feed. You know, it has a law that if you're going to sell it, it has to be safe. And then the EPA has the legal authority to regulate pesticides. So depending on the use of your plant, it might be regulated by 1, 2, or all 3 agencies. So for example, if I'm going to sell a blue rose, it's not a pesticide. A blue rose is not a food, so only the USDA would look at it. But if I'm going to, say, have let's just say I talked about the avocado, you know, the non-browning avocado. It's going to be eaten, so the FDA would look at it, and the USDA would look at it because it's a plant. And if I had a BT Brinjal, for example, EPA would look at it as well because the BT is a pesticide. A pesticide is not defined by any chemical qualities at all. It is defined by intended use. If you intend to kill a pest, it is a pesticide. So a fly swatter can be classified as a pesticide. So the USDA announced its new rules late last year, and we're actually allowed to do one SDN edit without consultation. So if I have my soybean, I can SDN one gene and work with it, plant it in the environment, use it for food. I can do anything with it. There is no requirement that I notify the government at all. Likewise, we're allowed one SDN2 edit without consultation as long as the source of the DNA is a cross-compatible species. Now, if we have 2 SDN edits, if we make more than one edit, if we edit more than one gene, we do need to consult with the USDA, and they will do a regulatory status review to see if those edits convert the plant into a pest. And they say they're going to take as much as 6 months to do that consultation. The nice thing is that we do not need field data for this. So for example, I can say, I'm planning to do this. Would you regulate it or not? Or 6 months is less time than it takes to edit something. So I can consult with them at the time I start editing. And by the time I have a plant, I would know if I'm going to be regulated or not. Now, if they review your materials and think it might be a plant pest problem, they will do a full review, and they want 15 months to do that full review. As of a week ago, that's how new things are, they announced that when in this situation down here, when we go to the USDA for a regulatory status review, they're also going to send it to the FDA so that the FDA has 2 weeks to decide if it's going to pose a food safety problem or not. So on that side, I really like those new regulations. But then we have the EPA, the Environmental Protection Agency. So let's say that our goal is to get disease resistance. Well, the EPA is allowing us one SDN2 edit, but we have to let them know that we are doing an SDN2 edit. We're sort of allowed one SDN1 edit with a lot of conditions. So for the SDN1, the DNA sequence has to be identical to any sequence we would find in the germplasm pool. The expression levels have to be no higher. And it's a lot of terms and conditions that I don't see this one being practical. But this one actually, I think, will be rather useful. And again, it's a matter of letting them know that we've done it, and that's it. Now, if we deviate from this, then EPA will make you register your edit or your transgene as a pesticide, which is a major issue because you have to register as a pesticide manufacturing facility. You have to trace the fate of everything, measure half-life in soils, and a lot of odd things. So in general, EPA rules, I think, have really delayed the deployment of disease-resistant plants in the U.S. Japan is a little bit strange. Their editing system is case by case. You do need to let the government know that, when you do one of the edits, 1, 2, or 3, you need to let the government know about it, and they'll look at it and decide case by case. But this is the only one where if you're going to make a cross with your edited plant, you have to let the government know that you're using it in process. And local governments can put additional requirements on there. So if you notice, I started going with the easiest systems down to the more difficult ones, which really gets us to the European Union, which is the absolute worst of all. And here's a map, and this map of the European Union looks really bizarre now that England and Scotland and Northern Ireland are gone. But in 2018, the Court of Justice of the European Union pretty much said that any modification that you make, if you're using technology that did not exist before 2002, it is a GMO. And on top of that, last year, France said that traditional mutagenesis, if it's done in vitro, is also a GMO. So most of the world is going one way, and Europe is going the other way. Some other cases, New Zealand, they're GMO in New Zealand, but in Israel, as long as there's no foreign DNA, and it is not a GMO, the government does need to verify it. Russia has actually issued an edict, it's not really a regulation as much as an edict, that gene editing is the same as conventional breeding. So they have the door wide open for at least SDN1 use. So to summarize some of the key points. Right now, regulations are really in a state of flux. Most of them are still being defined and fine-tuned. Here in the U.S., we have a new administration, so our regulations can change again. But different countries use different trigger points to decide if something is going to be regulated or not. It could be, is the food novel or not? Others are asking, the U.S. really is the one that asks, can it be done conventionally? If it can be done conventionally, it is not to be regulated. Latin America asks about the new DNA combination. Australia asks about templates. Countries like Japan and Israel say no foreign DNA. But what all of these have in common is that there's many exemptions from GMO regulations. In other words, they're not being regulated. They're not being classified as GMO because they're not, They're not being regulated as GMO. But that does not mean they're not being regulated, because every single country has laws that protect food safety in general, that protect the environment in general, and these products are not exempt from the laws that are applied to all other food or all other products. So the overview then, I've put green is probably the most science-based regulation here. Canada is stippled because they're still reviewing their regulations. Australia is wonderful for SDN1, but not for the other SDNs. Japan is a little bit weird. The US, again, USDA, FDA is good. EPA is terrible, which is why it's yellow. New Zealand is in red, and of course the European Union is red. I want to finish off by calling the attention to two really great resources. One of them is this Global Gene Editing Regulation Tracker. It's doing a really wonderful job. And then there's this new book that came out maybe 2 weeks ago, so it's hot off the press. So with that, thank you so much for your attention.
Thank you, Dr. Van Allen Parrott, Program Director, Institute of Plant Breeding and Genetics and Genomics, University of Georgia, for giving a beautiful talk about how these CRISPR plants are regulated throughout this world. I'm Dr. Benharlal, moderating this session. So we are getting a lot of questions regarding the CRISPR plants, how this is being regulated. Some of these questions we have shortlisted looking into the common nature. One of these questions is, we have some 4 questions. One of these questions is it appropriate to call CRISPR modified plants as GM crops? This is one of the questions raised by many people. We have taken this for you to answer, sir. Dr. Parrott.
So please repeat the question. Is it appropriate to call?
Is it appropriate to call CRISPR modified plants as GM crops?
No, but there's a bigger problem here. It's not appropriate to call GM crops genetically modified because, I might find a slide and show it to you. Every plant is modified. A GMO is not a biological term at all. A GMO is a legal term. It doesn't tell you anything about the nature of a modification at all. It has to do with, it's really just a legal concept. It's not a biological concept. If you give me 30 seconds, I want to find a slide to illustrate my point.
Thank you. And the next question is, what is the future of CRISPR technology in agriculture sector?
As long as the regulations are not, as long as the regulations are scientific and not cost prohibitive, it is huge, because what used to take us years to do can now be done in months and at a fraction of the cost. And I'm going to, once again, share my screen. And let's see. There. This is what I'm trying to say about the concept of a GMO. This is a real example. This is wheat rust. And in the United States in the 1940s, there was this epidemic of wheat rust, and none of the wheats were resistant to it. They found resistance to the wheat rust in agelots, which is a wheat grass, but it's still not wheat. So the question is, how were they able to move the resistance from wheatgrass into wheat? And because the two are not cross-compatible, they cannot be crossed. So what they did is they crossed the wheatgrass onto another wild wheat. Then that plant was crossable to wheat. And then they did years of back process, and then they used X-rays to break the chromosomes and get translocations, and they had to do embryo rescue in a lot of the early crosses. And at the end of about 14 years, they got a new variety of wheat that was actually resistant to the leaf rust. Now, if you look at the spike of the original wheat that they started with and the spike of the wheat that they ended up with, they're very different. And that tells us that when we moved the resistance from the wheatgrass, we moved a lot of other things. So using the technology that we have now with in situ hybridizations, here in orange, you can see the chromosomes of wheat, and this yellow chunk here came from the wheatgrass. And by the size of it, we estimate there must be about 400 genes in this piece. We only needed one gene, but we transferred 400. And this process has been repeated dozens and dozens of times in wheat. So every time you eat wheat, you are eating a little bit of that DNA. Now, so nowadays, we have the ability to go into the wheatgrass and take out the gene for resistance, engineer it into wheat, and only move that gene. But if we do it that way, it's called a GMO. But, so this wheat here that's been modified with 400 genes is not a GMO, and the one that we added one gene to is a GMO, which goes to show that it's not a biological term, it's a legal term that shows we use modern biotechnology to make the product.
Thank you, Dr. Parrott. And as the time is very short, we end this questioning session. And I thank Dr. Parrott for giving a very beautiful lecture on how these CRISPR plants are regulated throughout this world. Now I request Dr. Anita to take over. Thank you.
Thank you, Dr. Parrott, and thank you, Bernard. This is a great moment to welcome Dr. C.S. Prakash, Channapatna Prakash to be more precise, an alumnus of this university who is now the Dean of the College of Arts and Science and Professor, Plant Genetics, Genomics and Biotechnology, College of Agricultural, Environmental and Nutritional Sciences, Tuskegee University, Tuskegee, USA, as our next speaker. We are indeed proud to have you with us and are privileged as you are connected with this university for 3 decades. His research expertise is on genetic improvement of food crops of importance to developing countries and training of scientists and students in plant biotechnology. Dr. Prakash has also been actively involved in enhancing the societal awareness of food biotechnology issues around the world. He has earlier served on the USDA's Agricultural Biotechnology Advisory Committee and the Advisory Committee for the Department of Biotechnology for the Government of India. He is a fellow of the American College of Nutrition. He was recently named among the top 30 social influencers in biotech by Huffington Post. Dr. Prakash plays an active role in social media in promoting awareness and debate on issues related to agricultural biotechnology. His website, www.agbioworld.org, became an important portal disseminating information and promoting discussion in agbiotech issues among stakeholders such as scientists, policymakers, activists, and journalists. Dr. Prakash has been successful in impacting decision makers, the media, and the consumers in creating awareness of ag-biotech issues, especially on technology, development, and biosafety issues. He has also been instrumental in catalyzing the scientific community in many countries to be more proactive in the biotechnology debate and has lectured at dozens of countries. Dr. Prakash has a bachelor's degree in agriculture and a master's in genetics from India and has obtained his PhD in forestry and genetics from the Australian National University, Canberra. I request you, sir, to please give your talk.
Thank you very much. ನಮಸ್ಕಾರ. ನಾನು ಒಂದು ನಿಮಿಷ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡ್ತೀನಿ. ನನಗೆ ಕೃಷಿ ವಿಜ್ಞಾನ ವಿಶ್ವವಿಜ್ಞಾನ ವಿದ್ಯಾಲಯದಿಂದ ನಾನು ಪದವೀಧರ. ಅದರಿಂದ ನನಗೆ ಈ ಭಾಷಣ ಮಾಡೋಕ್ಕೆ ಅವಕಾಶ ಕೊಟ್ಟಿದ್ದಕ್ಕೆ ಬಹಳ ಸಂತೋಷ, ಕೃತಜ್ಞತೆಗಳು. ಥ್ಯಾಂಕ್ ಯು. ಸೊ ದಟ್ ವಾಸ್ my speaking in Kannada, just thanking my university that I am a very proud alumnus of University of Agriculture Science. So I'm really grateful to this university for having given me a start for my professional career. And I owe it to many, many good professors, including my advisor, Dr. G. Shivshankar, and many professors who helped train me and prepare me professionally. And also, I'm really glad to be speaking here along with many of my contemporaries, Dr. Ramanjini Gowda, who was a postdoc in my lab, and Dr. Savitramma, who was also a postgraduate student along with me in plant breeding and genetics around the same time. So I just want to provide a global view of what GM crops has been, its impact globally. But also I want to talk about some of the few examples of the research. There are literally hundreds of labs working on GM crops. And we heard a really good lecture by my friend, Dr. Wayne Parrott, on even the future, moving away from GM crops in many areas where we could simply do gene editing. And so to put that in the context of why we need whether gene editing or GM crops, I just wanted to remind my audience that, we have been modifying our crop plants for literally thousands of years. And great centers of domestication, India being one of them, for nearly 4,000, 5,000, 6,000 years, we have taken wild plants from the wild ecosystem and we moved away from hunters, gatherers, from the Stone Age, and we started agriculture by modifying these plants from the wild into cultivated. And a dramatic example of that can be seen here, where we could see in Mexico and Central America, they took teosinte, the wild ancestor of maize, and over a period of 2,000 years, 4,000 years, it was transferred into an incredible maize plant that we see today. And like this, we could see in every crop plant that we grow today as to how they have been transformed through those selection. And in the past 100 years, we have used crossbreeding, hybridization, and we saw, for example, mutagenesis and cell cultures and tissue culture. And in the past 25 years, we have been using transgenics, or the GM crops, which essentially means you introduce a gene from other species into the crop plants. And then moving forward, we heard genome editing is one of the hottest areas where we do not necessarily introduce a foreign gene into the crop plant, but instead of that, we modify a few nucleotides within the plant to bring about the change that we want. And GM crops, this were the very first GM crops were introduced in 1996. So they've been around only for about 25 years. And since then, today we grow them in about 30 countries, but more than 40 countries have grown GM crops. And some of them, especially in Europe, experimented with it and did not move forward. But on the other hand, country like India, where we started growing BT cotton, but did not approve any more other crops. But nevertheless, cotton has taken on, as we heard from Mr. Ram Kaundinya. Well, in Americas, especially where the United States is the leader, followed by Canada, and then Brazil, Argentina, we see a tremendous acceptance of these GM crops, especially because they grow some of these commodity crops such as maize and soybean and also cotton. And more recently, some of the newer countries that are embracing GM crops are seen in Africa, where, as you can imagine, their food security assumes a lot of importance, and so there's considerable interest in these GM crops. So totally, if you look at around 190 million hectares, almost 10% of the global arable land is planted with these GM crops, and about 17 million farmers grow these genetically modified crops. The soybeans, maize, cotton, canola are the four most important crops where this genetic modified technology has been adopted. We also see increasing prevalence of these transgenic crops in sugar beets and alfalfa, and there's a small amount of that in papaya, squash, and eggplant in eggplant, for instance, in Bangladesh. And when you look at the impact of these GM crops, they have been substantial, especially with maize and soybean and cotton, the three most important crops. There has been a marked increase in the global crop productivity of these crops, and to the tune of about $186 billion in farm income has been realized from that. And from an environmental point of view, these crops have also helped conserve biodiversity, because we have, by increasing productivity of croplands, we have not expanded the area of agriculture, and we have decreased the herbicide and the insecticide use, and also it has impacted carbon dioxide emission because of fewer use of machinery needed to spray. And overall, especially in developing countries, the GM crops have helped alleviate poverty and hunger, and especially including in India, because we have almost 7 million cotton farmers who grow these crops. And in India, BT cotton was approved in 2002, and including Karnataka is one of the places where experimentally the BT cotton was tested for 5 to 6 years, and there was much substantial biosafety studies were made, its effect on the environment, its effect on food safety, and it was released rather under strange circumstances, because farmers had already started growing these crops illegally in Gujarat, and so the government of India approved that in 2002, and since then this crop took off really in a very dramatic manner. And when you look at, and this is actually a picture from Australia, but it provides a good illustration as to why this BT cotton has become so popular. As you can see, on the left is the GM cotton, the BT cotton. On the right is the regular cotton, which has not been sprayed, and you can see the extent of insect damage on the right. And this is a good illustration of why this became so popular, so much so that almost 95% of the farmers today in India grow BT cotton, compared to almost zero before 2002. And not only the percentage of farmers has increased, and when you look at the productivity of this cotton in India, before BT was introduced, the yields were about 300 kilograms per hectare, and today it's more than 550 kilograms of cotton per hectare. And not only the cotton production has increased dramatically in India, and this has made India now the number 1 or number 2 cotton producing country in the world. And India, which used to be a cotton importing country, now has become a cotton exporting country. And more importantly, the amount of pesticides that we have used on cotton fields has also come down dramatically in the past few years after the starting of the BT cotton. But unfortunately, India has not approved any new traits of BT cotton, a newer version of BT cotton in the past few years. But nevertheless, the farmers have grown this herbicide-tolerant BT cotton illegally, and almost 1 million hectares of this were planted last year. Not only planted, but openly farmers have been defying and then advertising, as you can see here, that they are growing HTBT cotton. And this is primarily because there's no new traits been approved, and the primary developers of this cotton, like Monsanto, have moved away from developing any new traits, primarily because the royalties for this was cut down, and I'm sure some of the other speakers in front of me would be talking about it. And many of us were involved in helping bring awareness of BT cotton to India, and I was worked with many of the professors in UAS, like Dr. Ramanjani Gowda, for instance, Dr. Mahadevappa, Dr. Manjunath, and many others here. And this is one example where I was involved in a debate with one of the activists, Dr. Vandana Shiva, who has always been very opposed of this BT cotton, and you could look that up on YouTube. But what is interesting is India also developed using the same gene BT Brinjal, but this was not approved, and Bangladesh went ahead and planted it, and it's been very, very successful over there. And there was quite a lot of protests and people who were opposed to GM crops in 2010, and this was being considered. There was a lot of considerable opposition to that was seen in many quarters, that led to this decision by Mr. Jairam Ramesh, who was at that time the environmental minister for India. And I think this has hurt India very badly in 2010, the moratorium that was put on that. And I'm going to just talk about that towards the end as to my impressions of that. But nevertheless, as you can see, other countries have moved on, especially in Africa, which in fact many of our Indian companies, including Myco, are helping Africa develop some of these cotton crops that has not been approved here. And many countries in Nigeria just approved the growing of BT cowpea, and then they're also experimenting with banana, cassava, and many other crops in Africa. And just to give some examples, this is what the BT, the insect in cowpea that has been targeted using BT. And this is one example where Africa is doing considerable research on potatoes. And this is a late blight disease. And you can see here, this was an experimental plot that was done in Uganda, where the disease is so severe that only plants that survived are GM plants. Every other non-GM potato has died here. And this was again developed with a resistance gene from a wild potato that you see here, which you could develop from a conventional cross, which leads to a lot of undesirable types. But just by taking one gene, they were able to develop an incredible result. And similarly, plantains and bananas are also very important in Africa, and they are developing disease-resistant varieties of banana and plantain. And moving forward, one of the most important applications of biotechnology is going to be developing crops that are climate resilient, crops that are tolerant to heat, that are tolerant to drought, and even flooding conditions. And so there's been considerable research going on in that area. For instance, in drought-tolerant cotton, you can see one of these maize varieties that we grow in the US. If there is drought, this is what the yield that you will get. But this drought-tolerant variety, you can see the maize yield, how substantially improved it would be. And you can imagine technologies like this would be of great value to farmers in India. And also virus-resistant papaya that I mentioned, that is grown in Hawaii, resistant to the very serious disease. which is also quite prevalent here in Karnataka. And in the United States, we're trying to bring back the chestnut, with 4 billion chestnuts disappeared because of a blight disease, now coming back. And and this is eucalyptus. This is very close to Tuskegee, where they did this research, developed varieties that could tolerate the frost, which is an important problem, as you can see, in temperate countries. And flood-tolerant rice that was developed by Erie, not really necessarily through GM, but it was helped with using the marker-assisted breeding. But again, it shows the power of biotechnology in developing such flood-tolerant varieties, where flooding is a big problem in almost every rice-growing area. And many of you are familiar with the golden rice. It's a great example of humanitarian application of biotechnology to improve the nutritional value. This has also been done in maize, soybean, and also in banana. And a few other examples. And this is a citrus, the lime, where they put lycopene genes to improve the antioxidant content. And similarly, that was done with high lycopene content in tomato. It's also very useful for men with in preventing prostate cancer. There's clinical evidence of that. And more recently in the United States, they released this papaya variety that has this beautiful pink color that is primarily from a consumer point of view. And other examples of biotechnology include developing fruits and vegetables that can last longer without storage, without cold storage or processing. And this is again an example in tomato. As you know, tomato rots very fast, and by just turning off some of the ripening genes, scientists were able to extend the shelf life of tomato. And we can do this in practically any climatic crop. And also in the United States, we have released a potato variety that doesn't brown very quickly. And so this is very, very useful for French fries preparation. As you can see, as you know, McDonald's and other places, this is very popular. And also the apple that doesn't brown, and this is very popular with school children who take apple slices as a part of lunch, and it doesn't turn brown, unlike the conventional apple. But also we know from our experience that BT crops also have less mycotoxins, they are more healthier. And another important application is use of plants to produce vaccines and antibodies. And right now, there is research going on in producing vaccine against coronavirus with this technology. And Dr. Ramanjani Gowda did some exemplary research on producing vaccines against rabies and other diseases and showed the proof of concept right at UAS. And also another application is in developing beautiful ornamental plants like this blue rose, again, which is available in the United States. It's developed in Japan and it's produced in Colombia. And again, this is just an overview of many of the possibilities of GM crops that I provided here, just to give some specific examples. But an important point, as we learned from other speakers, is that we can do all the research in the world like it has been done, but if it's not accepted or if it is not brought into the market, then it's of no use. And so the biggest question a lot of people ask is how safe is GM food? And this is where, as scientists, I think we have a responsibility to help public understand the safety of this technology, as to how well this is regulated and how it has been tested very well in the lab. And so much so that it takes about 10 to 15 years of testing some of these biotech crops, and an average about $130 million is spent on testing. And so where conventional crops develop the same trait by mutation or hybridization, it doesn't need any regulatory testing. And so in India and in many other countries in the world, there is definitely an ongoing relevance of GM technology, because it can help increase the farm productivity, it can bring greater global food security, it can conserve biodiversity by ensuring that we don't expand agricultural land area, and also by bringing more conservation tillage. reduce the environmental footprint of agriculture by reducing pesticides usage and other chemicals, including fertilizer, because a lot of crops with improved nutritional nutrient uptake are being developed, and help mitigate the climate change effects on agriculture, increase the stability of food production, and overall bring many economic, health, and social benefits. And so, as you can see, many countries are moving forward, and India too can benefit from biotechnology, move beyond BT cotton, as Dr. Ram Kaundinya talked about how pulses, oilseeds, and many other crops of vital importance to our nutrition can be improved by using this technology and the emerging new technologies such as gene editing that Dr. Wayne Parrott talked about. And having worked in India related to GM crops in many years, I just wanted to again emphasize that putting the moratorium on 2010 by Jairam Ramesh was a real blow to agriculture biotechnology to India, because it impacted the overall science progress here. Many young people who would have gone into agriculture biotechnology did not go, or many of them moved away from this area, which is a big loss to this sector. And there's been not any much new investments. Many small companies that were there, they can either just moved on into different areas. And so there's so much research pipeline was really been impacted because of that one decision, and several other decisions that kind of impacted ag biotechnology, including the price controls on the BT cotton. So just like this conference now it is being held, we need to have more of this, where academics should be speaking up with this technology and help bring more awareness of this. And seed industry was involved in this meeting and must continue to contribute more in such communication outreach efforts. And we clearly need more favorable policies for this, both at center and at the state level, simply because there is so much at stake. And India, with our such large population, huge challenges, climate change, and everything, we need every tool in the toolbox to make sure we feed our population in a sustainable and safe manner. And if those of you are interested in following this, I have a good presence on social media, and both on Twitter and Facebook. I encourage you to please follow me. My handle is @BioWord here. Again, thank you very much for giving me this opportunity.
Thank you, sir. Thank you, Dr. C.S. Sir, for providing a broad view of global impact of Gmos on agriculture productivity by showing actual facts with examples. So now we have received many questions with respect to your talk, and for most of the questions already you addressed the answers, and we have selected few questions for you, sir. So first question is with respect to there is the efficacy of this genetic engineering on complex traits which are governed by many QTLs.
Right, exactly. That's a very good question, and Dr. Parrott and others can chip in. In the beginning, we were essentially much of the GM crop technology, we were able to transfer just one or two traits, but more recent studies show that we have been, there is great possibility of transferring even chunks of the chromosome, and the chromosome engineering and even QTL transfers are being worked on. Just one example is our own US scientist, a good friend of mine, Dr. Upadhyaya, who works in Sr Rao in Canada and Australia, and his group published a paper just a few weeks ago where they were able to transfer 7 genes for wheat stem rust resistance into wheat. And they were telling me now they have a cassette with 9 genes going on. And so it's a very good, important question, but I think the science is moving forward in a way that we are increasingly able to transfer complex traits. But I think one of the best way for handling complex traits is really the marker-assisted breeding and genomics. And again, ICRISAT here, with Dr. Rajiv Varshney, to give an example, has shown a great leadership and has to show how that could be possible. And because they are not GMOs, they're not subject to that regulation and the public PR, other problems that we have. And so that is a good way to go with complex traits.
Thank you, sir. Second question is, can we use nanotechnology for the improvement of yield of GM crops?
Yeah, there are, there is an application of nanotechnology in some ways. For instance, just like current mRNA vaccine that is brought about by both Pfizer and Moderna, they've used nanotechnology to coat that mRNA vaccine. And so there has been a great effort in such for the delivery of DNA into crop plants, including the particle bombardment technology, which is a kind of a nanotechnology to deliver genes into crop plants. But you are going to see greater convergence of not just nanotechnology in agriculture, nanotechnology with genomics, gene editing, but also many other newer technologies, including robotics and drone, artificial intelligence. All are converging onto the technology. I think we are looking at the next version of Green Revolution is going to be a combination of both gene and IT, the computational forces here.
Thank you, sir. Thank you for your wonderful presentation. Now I'll request Anta Madam to invite for next speaker.
Thank you.
Third speaker for the day is Dr. Vibha Ahuja. She's the Chief General Manager, Biotech Consortium, India Limited. Dr. Vibha Ahuja is MSc Honours and PhD in Microbiology from India. She has more than 20 years of experience in the area of biotechnology and biosafety capacity building. These include undertaking, planning, and implementing capacity building activities, imparting training through seminars, workshops, national and international training programs, and preparing well-researched publications for various stakeholders related to biosafety issues. She has been actively engaged in providing support to regulatory authorities in India, has expertise in development of guidelines and also implementation of regulatory system, including processing of applications. She has wide experience in issues related to the Cartagena protocol on biosafety and is well versed with relevant decisions and developments. Madam, I request you to please present your talk.
Thank you, Anita. Thank you very much. Can you see my screen? Is it visible?
Yes, madam.
Okay. Thank you. A very good morning to all, and many thanks to GKVK for giving me this opportunity to share my views on this very important webinar, that is the current scenarios and path forward for GM crops in India. It's been always a pleasure to be associated with GKVK. We have done several workshops in the GKVK campus itself with the colleagues in the biotechnology department and with the help of the the university management. Now today we've heard very nice presentations from our international experts on the potential of this technology, the genetic modification, as also the gene editing, which is the new tool available to the agriculture scientists for modifying these crops and deal with the challenges of the agriculture. So the topic that has been given to me is about the risk assessment strategies in GMOs and biosafety, and I would like to share some thoughts on that, particularly in the context of the Indian system also. So if I, just one second, I think this my slides sort of stuck. Yeah. So I will, if I go through the presentation, I would like to discuss a little bit about the historical perspective to the risk assessment, the need for risk assessment, what are the components, Where are we placed as far as this risk assessment or safety assessment of the GM crops is concerned? Some key consideration and the challenges that we are facing. So if you look at the historical perspective, we heard from our esteemed speakers that, since the initiation of the GM crops in 1990s, and now we have a huge area under cultivation. So it is not that the biosafety or risk assessment has come suddenly, on the table. Right from the 1980s, when the GMO were developed, the applications in agriculture and healthcare, they prompted countries to create regulatory frameworks for safety assessment, specifically targeted to these products. In fact, the first set of recommendations have come in 1975, and these formed the basis of subsequent regulations in US and other countries. The focus was more initially on the use of technology and the safety within the laboratory. However, as the end products came for the benefit of the society, the focus is shifted to the technology itself with the release of the products. Now, what exactly is the objective of the risk assessment? And we have these biosafety regulations for managing that. A national biosafety regulatory framework is to ensure regulate the production and release of GMOs in all countries with biotechnology programs. And so in India also we have this program, since we are actively involved in the production and research and scale up of the GMOs and use of these technologies. It ensures the safe access to the new products and technologies developed in the country or elsewhere when they are imported into our country, and it provides a level of public confidence that products placed on the market have been assessed as safe before they came to us. Coming to the process of risk assessment, what exactly is this? The generation, collection, assessment of information in a structured way in order to evaluate the impact of human activities to health and to the specific human activity to health and environment associated with the release of GMOs. It is considered to be a function of hazard and exposure. I'll explain you a little bit further on that. It is a tool to gather information and analyze so that the decisions can be made about any new technology. It needs to have a clear purpose, use scientific methods, but we have to remember all activities carry some risk, and there is no such thing as zero risk. Risk assessment is not unique to the genetically modified organisms or GM crops. It is conducted in every sphere of life that is around us. It is to determine the impact of many human activities, new technologies, industrial chemicals and pesticides, which as agriculture scientists you would be most familiar with. Even the engineering, setting up a dam, we do a scoping exercise and see what exactly is the risk of setting up here. It's a very important tool for decision making. Coming to our genetic modified plants, since we are talking about plants, so I'm just going to focus from GMOs to GM plants now. Why do we need to do the risk assessment in GM plants? Because there are novel or modified characteristics in the plants. Of course, we have the biosafety regulatory requirements, which we have to comply with. And then there are also international commitments, which we will go through it slowly. So if we look at the novel or modified characters in GM plants, you see a GM plant carries a new gene, and this new gene can be introduced into a plant from any source, whether it is bacteria, virus, fungi, animals, and therefore we are overcoming taxonomic or reproductive barrier. And this was the reason that the scientists considered it a responsibility to build into the process a proper, structured, methodical risk assessment, so that before these crops come to the market for the use by the farmers and the society, there should be there should be a risk assessment done, and then all the concerns are allayed. Now, the second is the regulatory requirements. As I indicated in my first slide, that when this technology came, because of these concerns, all countries have set up the national biosafety regulations. And in India also, we have set up these rules way back in 1989, which is the rules for manufacture, use, import, export, and storage of hazardous microorganisms under the Environmental Protection Act. These are administered by the Ministry of Environment, Forest and Climate Change and the Department of Biotechnology through a series of committees. Then we have the international commitments. India is a signatory to the Cartagena Protocol on Biosafety, which is also mentioned here. Now, in addition to the Cartagena Protocol on Biosafety, where we are more focusing on the environmental biosafety in terms of the impact on biodiversity, there are other international forums for GMOs and biosafety where also the risk assessment issues are considered. The most prominent of them is the Codex Alimentarius, which has worked a lot on the food safety aspect. Then we have the OECD, where lots of resources are available to aid in a systematic risk assessment. And then, of course, Cartagena Protocol, to which India is a signatory. We are also a member of Codex, but an observer in the OECD. Now, what is the purpose of this international forum? Because the internationally accepted guidance like the Codex, guidelines, the OECD resources, the Annex 3 to the Cartagena Protocol, they provide the necessary scientific and technical foundation for a common approach to the GMO safety assessment, and they lead to a very efficient resource utilization by the regulatory agencies. And the objective is that there should be a greater consistency in the dossier submissions and dossier reviews, which would ultimately lead to a greater synchrony in submission timings and also the decision making. With this background of why we do this risk assessment and what are the resources available, we'll just move more specifically on the strategy which is used for risk assessment when we have to do it in case of GM plants. You see, there are lots of safety concerns which have been listed because the genes came from different organisms. So the initial issue was that, okay, this particular gene is not in our food chain, so should we check for the toxicity and allergenicity? Is there any unintended effect? So we should try to do the compositional analysis. Then there is, does it become more weedy? Is there any possibility of outcrossing, or there are effect on non-targets and things like that? So I've not listed all the concerns, but these were the issues which were in the minds of the scientists, and that's why the GE plants risk assessments are planned in a very systematic manner to address all such concerns which could arise from insertion of new genes. So the components of the safety assessment here, we basically divide them into three parts. First is the molecular characterization. The gene that we have inserted, what protein does it produce? Now, this is the basic, what is the protein being expressed, and we have to characterize that and do it in a very systematic manner. And then we do the food safety assessment and the environmental risk assessment. If you recall the words I said, impact on human and animal health and the environment, these are the two major considerations. And these two are very distinctly done, as I'll very quickly explain you. You see, GM foods or any foods are complex mixtures of macro and micronutrients, fibers, anti-nutrients, natural toxins, and health-promoting substances. So when we were set out to develop a risk assessment strategy for them, it was very clear that the procedures that are used for single food additives will not be applicable here. We cannot have the principles of acceptable daily intake and so on. And that is why a decade of consultations started, way back in 1990 by the FAO, WHO, OECD, and other agencies. And finally, in 2003, the Codex Alimentarius came up with a guidance and an agreed approach, which is the comparative approach. Now, this is the basis of the safety risk assessment in the GM crops, where we say that we compare the GM plants with a traditional counterpart that has an established history of safe use. So what does it mean in the practical terms? That my BT brinjal will be compared with a normal brinjal. And I'm only going to study the impact of what I have added there and not looking at it as a new product, for which I have to do, lots of, new product assessments. So this comparative approach is also referred to as the substantial equivalence. So comparative approach is the first, as I said, the baseline for the basic strategy for the risk assessment. But in addition to that, the generalized risk assessment paradigm will have another 2 points. which means that we do conduct it on a case-by-case basis. Every gene crop combination is different, and that is why we have to treat it differently. In the opening remarks, Mr. Kondanya also mentioned that, we should not be treating GM crops as one entity. It is not like every crop, BT crop, BT Brinjal, BT GM mustard, and everything is different. It has to be assessed differently. As I said, the genes have been taken from the different organisms. Sometimes genes may not be taken from a different organisms. It could be a same gene from the same plant, and a very typical example which I quote always is the genetically modified rubber research which is going on in our country. They have not taken gene from outside, they've taken a gene from rubber itself. So we cannot equate it to the risk assessment parameters cannot be equated for all the types of crops. We have to see the benefits, we have to see the risks and align our safety assessment process on a case-by-case basis. It will consider the characteristics of the plant, introduced trait, and the receiving environment. So as I already indicated that weediness, invasiveness, gene flow, these are all basic concerns. And even in case of environmental risk assessment, it will be comparative approach. My non-transgenic non-GE counterpart will be there. And then I will see what change has happened. So like, for example, the last one, which is very favorite of the activist organizations, saying the impact on biodiversity. So I have to see that how using a single variety is impacting biodiversity otherwise, or introduction of that GM1, how it will differentially, affect it. Is there anything additional, which in most cases you will find that it is not. Then, the process of doing this is a very systematic. We start with the laboratory work, we move on to the greenhouse. There are some studies done by the scientists. Small-scale field trials are done, then large-scale field trials are done. In India, we call them biosafety research level 1 trials and biosafety level 2 trials. And then there will be what we call unconfined release. Overall, to summarize how we do the risk assessment is, we do the core characterization, which means what gene, what is the source of the gene, doing the complete molecular characterization, insert, copy number, this is all done by the molecular biologists, what protein it is expressing, history of safe use, consumption, function, specificity, and so on. And then we do the food and feed composition. On a case-by-case animal performance assessment may be done, and then environmental issues will be addressed. So now all this is, like I said, the basic considerations, but they will apply on a case-by-case basis. For example, if I have to see a protein, which we have been consuming, it's from the same plant, edible plant itself, then there is no question of toxicity and allergenicity to be done because it's already in our food chain and is being adequately used. I won't go too much into explaining the Indian regulatory framework, but I wish to highlight that we have a very good system in terms of the availability of the guidelines, which has evolved over time for every stage of the development of the GM crops, and doing the risk assessment, contained use, whether it is the confined field trials or the food safety assessment, where the ICMR and DBT had joined hands and came up with these guidelines, and environmental safety assessment, where the Ministry of Environment and DBT came, and all our guidelines are based on internationally accepted approaches and very, very much up to date. So one thing which I want to specifically highlight is that risk assessments and approvals are event-based. What do we mean by event is a genotype produced from the transformation using a specific gene construct. So if you look at this pictorially, and if this is the DNA, and I've taken this gene and I put it here, so this is one event. If it is placed in another position, then it will be another event. So just see the robustness of the process is that we are doing it in a very detailed form. Even if it was the same gene and the same crop, and if it is affected at another, insertion is at another place, then this process will, some of it, the testing would need to be redone. So in India, we have three, we heard Dr. Prakash say that there was a moratorium on Brinjal, but I would just like to submit here that there have been 3 products for which the complete risk assessment has been done In India, they were considered for environmental release, although the decision is pending or moratorium or that. BT cotton was approved, but these two products also, which are in the pipeline, I would say, or moratorium, or this is still under consideration. So these two also, the complete risk assessment as per the Indian guidelines, taking into account the internationally accepted principles, has already been completed. Now, Dr. Prakash mentioned just before me that there has been a very negative effect of these moratoriums or delays in the approvals. So I would also like to highlight that in 2014-15 we had done a survey under a project of the Ministry of Environment and Forests, and it was really very fascinating to see that we had so much of research going on in our country before that virtually 85 different crop species were found to be under various stages of research and development in India. And this was a survey wherein 1,150 scientists were contacted from almost 350 institutions. This report is available on the website itself, but very discouraging to see that, of course, what Sir said is very true, that many of this research has actually been halted, and we have not been able to release any product after the cotton, as Mr. Kondanya said in the beginning. So anyway, all such information for the guidelines, these surveys, and whatever we have, everything is available on these two websites, which is the Genetic Engineering Approval Committee website and Appraisal Committee website, and the Indian Biosafety Knowledge Portal created by the department. Now, after that, I've given you a broad overview of this strategy. I just wanted to share some of the challenges that we have faced in terms of the types of risks to be addressed, understanding of the types of risks to be addressed. So what has happened is that, if we divide this risk into the kind of risk, this is true not for GMOs alone, this is true in general. The risks are actually divided into three categories: probabilistic, hypothetical, and speculative. So where we are stuck in India is the speculative risks, where we are hypothetical and in spite of anybody would say, you have such a very good system, you are saying there are international guidance and everything, national guidance, so why it's not happening? It's happening because we are stuck in these two kind of categories, and more rather than science-based, somewhere there is what we call a biopolitics which has happened. So my request to the regulators and to the esteemed scientists who are the members of the committees and others is we always feel that the focus of the risk assessment should be on the probabilistic or maybe some hypothetical risks, but not the speculative ones. And there should be discussion on the risks which are testable by empirical means rather than any unsubstantiated logical possibilities. Definitely, if there is any dispute or uncertainty, it can be resolved through the further studies. And if it is inconclusive, then we have the provision of risk management. So the decisions should actually be taken. So risk assessment is done, but if the decision is not taken, then it is a very, very, discouraging scenario for all concerned. As was mentioned in the morning, that everybody is stuck on what next to, should we go ahead or should we not go ahead? The risk assessments have to be based on science, and we must ensure that the information requirements are scientifically justifiable, and there should be a biological significance of any differences or anything which should be treated. So one thing which we have noticed and which I just wish to bring to the notice of this August House, all the esteemed participants, that risk assessment should not be driven by a risk communication agenda. Oh, we feel this could be a risk, so put another study into it. So that, stops that delays the whole process. And like Dr. Prakash said, years of research and, so much money is spent, and we must have a risk assessment, management, communication very, very, separately and separately dealt with. It should be very transparent. There are some things which are also published in the by our regulators in the website, but at the same time, the question is in the decision making, where we are not able to understand how much socioeconomic concerns or how much, other considerations would be taken, and this should also be a kind of, on public record. Some of the key issues, this is my last slide, on that need to be addressed presently, if in spite of good risk assessment strategies, the hard work done by our regulators in, the DBT and the ministry also in coming out with the state-of-the-art guidance, etc. But still we are not able to see these products the light of the day. Some of the issues that we need to discuss is the applications in healthcare are widely accepted in our country, but there is definitely in agriculture we are facing this problem. So is the technology the issue, or there are other issues which are there? Moratorium on the release of Bt Brinjal, it has already been highlighted. This has been definitely a step backward. The commercial approval of GM mustard is still pending. The non-receipt of the NOC from the state governments, this is a step which has hampered the research in a very big way. And particularly even I would say the private sector, of course, but our public sector institutions are greatly affected because they don't have also the resources to go here and there and seek these permissions. We have a PIL in the pending, which is since 2005, and it is still not resolved in our country. There is definitely, it was pointed out in the morning that there is a lack of adequate awareness in the common public. But more than the common public, I would say the one which we are now holding, the State Department of Agriculture and of farmers, etc. These communications are extremely important to ensure that to break this stalemate and apply take benefit of such robust procedures that we have already put in place and take this technology forward. Thank you very much.
Thank you, Dr. Vibha Ahuja, Madam, Chief General Manager, BCIL, India, for providing detailed information on risk assessment strategies, particularly with respect to GMOs and biosafety issues. Hope in future we can expect the release of whatever the brinjal, mustard, etc. So we have got many questions for you, Madam. Among that, we have shortlisted 2 questions. So the first question is mainly on regulatory approvals. How India may be benefited by timely regulatory approvals? What can be done at the regulatory end and at the applicant end for time-bound regulatory approvals?
Of course, India would be greatly benefited. We would be able to make use of such nice products which are in the pipeline. We have a lot of challenges in agriculture which are to be dealt with. And, I was just in the last week, there was a very interesting, discussion on, transforming agriculture 2030 and so on. But we see that many of such things can be achieved only through the use of innovative technologies. And innovative technologies can come only if we have the timely, a very supportive regulatory system and which can, take timely decisions. Time is money in all these things. When the products are delayed endlessly, then even to maintain them, even to, carry forward other studies and things like that, it costs a lot. And it discourages this lack of motivation to undertake this kind of a research. So the timely functioning of regulatory system, timely decisions and considerations as per the laid out procedures, that is very important.
ನೀವು ಡೆಸ್ಟಿನೇಷನ್ ಎಲ್ಲಿ ಕೆಲಸ ಮಾಡ್ತಿದ್ದೀರಾ ಬಳ್ಳಾರಿ ಎಲ್ಲದು ಹೋಗ್ಲೇನ ಮಾಡ್ತೀರಿ.
Hello. Thank you, Madam. Next question is, how to tackle unauthorized and unapproved GM crops used in the markets?
You see, in the morning, Mr. Pandanya mentioned that there is a need from the farmers. So how do there will be unauthorized activity if we delay the decisions a lot. Because definitely, as we heard from Dr. Prakash's presentation, such projects are all around being adopted. They are very, very useful. And they are bringing in a lot of benefits to the farmers, to the who want to use them. So the thing is that if we are able to have timely considerations, fuels, etc. Itself will help in, doing away with this kind of an unauthorized cultivation. That's one. And secondly, of course, the risk management procedures. Capacity of the stakeholders, cultivation it has to be controlled by state agriculture departments. It has to be controlled by the other risk management layers. Like when we do the trials, there should be very strong monitoring processes. Steps have been taken in this direction, but maybe even more steps are required probably to check all these things. And this would definitely help. The state agriculture departments, BCIL, when BT cotton was approved, we had done a lot of activities for the state agriculture departments through the Ministry of Agriculture in every cotton district and every cotton growing district to inform. There was a whole unauthorized cultivation of at that time, of course, the unapproved hybrids, not the events, all across the thing, and there were fly-by-night operators and illegal cultivation was there. So a massive exercise was undertaken to involve the state agriculture departments by the Ministry of Agriculture, actually, a big program. So maybe things like that, we need to do it again, do much more capacity building so that the real developers, who are there and the quality products are there in the market. But at the same time, I think that there is a need for timely consideration of these products. The world is a global, we call it a global village, and if the other countries are benefiting out of it, why not make use of these technologies here? That's also a very pertinent question in this regard. Thank you.
Thank you, madam. Thank you, madam, for providing wonderful presentation. So now I request Dr. Anita Bhatta, madam, to continue for the next speaker.
Thank you, Dr. Nagesh. I now invite Dr. Sr Rao for his talk. And Dr. Sr Rao is former advisor, Department of Biotechnology, Minister of Science and Technology, Government of India, and is a graduate in agriculture with PhD in mycology and plant pathology from IRI Delhi. And he has a postdoctoral from the Totori University in Japan. And he was a visiting scientist at the Wake Agricultural Experimental Station, Adelaide, Australia, and has specialized in molecular pathology. He served in various positions in the Department of Biotechnology, Ministry of Science and Technology, Government of India since 1989, and was actively involved in the establishment of oil palm cultivation in India, several sophisticated biotech infrastructural facilities, holding bilateral collaboration with Asian and European countries, introduction of golden rice for research in India, formulation of national biotech policies, strategic planning and investment matters. He served as advisor for science and technology for a period of 3 years, 2004 to 7, to Minister for Science and Technology, Government of India. During this tenure, he initiated important programs on public health access in villages through public-private partnerships, science and technology interventions and judiciary reforms, technology assessment of bioenergy and biofuel resources, and various issues of science and technology and public policy interface. He served as member of several technical committees of the Government of India, academic and research councils of universities, institutes, member Golden Rice Humanitarian Board, elected member Asia Steering Advisory Committee on Capacity Building of Cartagena Protocol, Secretariat, Convention of Biodiversity, Montreal, member Liaison Group on Capacity Building. He specializes in core and cross-sectoral policies, issues of biotechnology development, regulation, safety, public-private partnership, international relations, and biotech R&D, innovation and development, and public concerns and consensus building. Sir, I invite you to please give your talk.
Hello, can you hear me? Hello?
Yes, sir. Yes, sir.
Can you see my slides?
Yeah.
Okay. So thank you very much. And first of all, I thank the university authorities, Dr. Savitrama, the Vice Chancellor, and the this FSCI, and also Agri Innovation. In fact, this is one of those which are series to be conducted in many universities by FSCI. The first one was conducted in University of Hyderabad. I gave a talk there also. But somehow this topic is very close to me, the scientific consensus on safety of GM crops. As Dr. Kaundinya and many others have alluded, that there is no depth of scientific consensus on GM crops. And but where is the problem? Now I'll basically address from the point of the problem actually. Now if you see the current status, as has been already told by many speakers, BT cotton has been approved, and we know what is the fate of it. It has spread very widely. BT Brinjal was given a moratorium. I'm just giving the ministers who are in charge, because by saying that approval by the government of the day, the government of the day is represented by these ministers. So it is their own personal view sometimes. And there are also court cases on BT Brinjal, as my previous speaker spoke. And there is also court case on GM mustard. There are cases going on one after another on these crops in Supreme Court, and nothing has been resolved. And in the midst of this, there has been a scientific consensus by various agencies, as have been listed by Dr. Prakash. As early as in 2016, the National Academies of USA came together, and the whole report they submitted after consulting several literature sources, experts, diverse disciplines. They said that in general, it has been reported in New York Times, the gist of this is to mean that GM
now please come to the slide show.
The slides are not seen?
Slides are seen, but you should come to the slide show.
No, what about? No?
Yeah, fine.
Yeah, okay. So you can see that the GM crops are safe as declared by National Academy of Sciences. And similarly, the Nobel Prize winners, several of them and thousands of scientists, they said stop bashing GMO foods. You can see the website, support to GM precision agriculture. And this also was very openly advertised, and the consensus was widely told. The environmental impact have been shown repeatedly to be less damaging to the environment. And in fact, it is a boon to global biodiversity. Such open and straightforward scientific consensus have been published and then advertised and campaigned widely all over the world. But notwithstanding, there are also other agencies in Europe. The European scientists, about 433, I'll tell you, the European situation is different. In fact, Graham, he published a paper long ago about the global benefits of GM crops, which was very sensational. And in 2021, he made this statement that even though there are so many 4,300 science-based regulatory assessments conducted in 70 countries, European politicians are not convinced. They are convinced to accept COVID-19 vaccine, including mRNA vaccine, which are also developed using genetic engineering. Their stance is considered as inconsistent. This is what our economist, who was very famous, Graham Brooks, who told many things about the benefits of the GM crops and published several papers on this. But irrespective of that, many European groups have formed a network of environmental activism, and these European scientists have been selling that all this scientific consensus which has been shown is an artificial construct. We are not convinced about many of the points that have been raised by these consensus documents. And some of them they list as there is no consensus on GM food security because there are no independent studies. They're all mostly done by the companies. This is what their apprehension is. There is no epidemiological studies in investigating potential effects of GM food crops. One of the things which people say that what are the long-term effects? And nobody tried to define what is long-term effect. Is it 20 years or generational, multi-generational? And they don't accept, although the trillions of GM meals have been fed both to the humans and animals, they are not in a position to accept those studies that they want, detailed epidemiological studies. And the Royal Society of Canada also was highly critical on regulatory system at one stage that is being highlighted as against the scientific consensus. The EU conducted a very big study of about 27 projects have been given, but some of the EU report was not scientifically giving a very great evidence from terms of long feeding of animals. So list of several hundred studies does not show GM safety. That's what they say. There is no consensus on environmental risks of GM crops. So international agreements, as my previous speaker said, that we have international commitments. But these international agreements are mostly read by environmentalists and the toxicologists. And they follow a precautionary principle, which says that you have to analyze the risks before you take any decision. And there are potential risks. That is being interpreted in many corners, that there are international consensus that there are potential risks. So when there are so many risks, can you convince me that we are out of risk? So all these, what you call arguments and counter arguments are there for scientific consensus, which is on the other side, is very convincing. But it is also very important to know that Euro bills are made with BT cotton, transgenic BT cotton. And there is a lot of organic momentum in the Europe who also attack many of the scientific consensus documents in a way that they suits to their ethos. And for example, organic cultivation is very popular. So they would tear apart the scientific consensus when dealing with organic cultivation and promoting organic cultivation. For example, you just see one of the famous celebrities, Julie Delpy. She says, I eat organic food and drink only green tea, gallons of it when I am writing. I smoke cigarette, but organic ones. This is the hypocrisy in most of these organic debates versus the GM crops. Well, they can smoke, but it is organic, but they hate GM, even though smoking has been proven very well responsible for cancer. So the question arises, in the absence of scientific voices against the scientific consensus, and there are scientific consensus on the other hand by eminent Nobel Prize winners, several of the reports, risk assessment reports, and there are also what you call the National Science Society, National Academies report. With all these reports coming between 2015 to 17, so is that having any impact on the what you call the expert voices having any impact on real implementation or the speeding up of the approvals? There has been a beautiful analysis by Penn State people along with Rutgers and many other universities. I recommend that most of you should read this article, how scientific consensus has no importance in communicating or in pushing the public acceptance. This diagram just shows you that people still go for non-GMOs compared to GMOs even after sensitizing them, that there is a scientific consensus. So this is a dilemma, that whether scientific consensus can really push the case of public acceptance. So normally these consensus assume that the hearts and minds of those who are ideologically or otherwise predisposed reject issues that challenge their views. And communicating consensus assumes that rejection of scientific consensus occurs because people are misinformed about it instead of recognizing that they may have ideological reasons to reject. I feel that scientific consensus alone, even though it is available in plenty, there is no doubt about it. In short term, these scientific consensus reports and the presentations of hard facts about safety of GMOs do not appear to be effective in changing the attitudes. The reason is something else. For example, I am shifting the gear towards another issue about scientific consensus. It was that soon after my superannuation, I made a statement as a chairman of the Food Safety Authority panel in the Food Safety Authority of India that no risks are reported from GM crops for decades. So there was a huge number of question and answer session published in Indian Express. Within next day, the activists started objecting that FSSA has a chairperson of this panel, will turn the body into promotional body for GMOs and GM foods. He is not qualified to fulfill the mandate of this panel, and it is not clear why a GM crop promoter and agriculture scientist is heading the food safety panel. Now, a food safety panel is a multidisciplinary, panel. It is not just agriculture scientists who is important, who is toxicologist, nutritionist. Everybody is a part of the food safety authority. What I am saying is that it's not only scientific consensus, but it is the scientists who is also directly attacked by the activists, therefore making them demoralized to do any further activities. So Pest is a very arm twisting activity by a lot of activists that goes on, and therefore some of the government authorities do change their committees with people who are in favor of their activists who are pressurizing. Now, for example, the marketing and psychology researchers asked 2,000 US European adults for their opinion on GM foods. How well they thought they understood genetically modified food. Despite of scientific consensus on GM foods, particularly emanating from the US academies for human consumption, 90% of the study respondents reported some level of opposition to GM food. The problem is, in the society, you have a set of people, including some scientific community people, who their findings suggest that the minds first required to appreciate what they don't know. People should have a habit of saying that I don't know many things. I would like to learn. Any amount of awareness campaigns, sensitization to any level, from agriculture officer to ministers, educational intervention might not work very well to bring people in line with the scientific consensus unless they accept that they are learning something which is based on science. So what happens is, most of these technologies, if you see, they are started with the scientists, academies, and then public media will pick up. The activists come in and they trigger the event. Legal cases have happened. But I'm telling in the Indian, not only Indian context, but many environmental issues, the diagram applies. Now the Indian situation is such, while pending legal cases are there, and on the background of scientific consensus, the politicians are playing a major role and they are taking a public positioning. Unless the political will is changed, the regulators and the scientific consensus alone are not any amount of awareness campaigns, because farmers are also interested. As my previous speaker said, they are interested to even do unauthorized cultivation. Now, where the problem lies in India, because the topic given is scientific consensus in India. So I'm just switching to the problem in India. With all this background that we have on science and scientific risk assessment, good regulatory framework, where we are stuck up. We are in a big dilemma actually. It's very difficult to explain. I'll tell you, in 2002, there was a minister by name Dr. Balu. He made a very daring statement in the parliament that we have already a place regulatory framework for dealing with GMOs. It oversees the development of GMOs from laboratory to large scale. The biosafety framework in the country is quite exhaustive and elaborate, as several countries, nation, region, and even beyond are trying to develop their system based on Indian regulatory framework. That is a starting point where a minister openly admits that regulation is good, science is good, and we are taking all precautions while approving. During his time, in 2002, BT Cotton was approved by. He faced a lot of questions, but he daringly answered many of these questions, both with the scientific help, but also his own intuition of the public perception. But as we entered into Brinjal era, the same thing turned around in the same ministry. It became a big public issue. Science was taken on the roads. Scientific consensus was discussed on the roads, which was developed by the GEAC risk assessment groups. And then what he said finally, a political statement he made was, moratorium till such. This is very important statement I show in many forums. Please don't ignore this statement. It's a very loaded with science. Moratorium till such independent scientific studies established. I tell you to the whole audience, the regulation does not depend on independent scientific studies. If it were to be so, none of the COVID vaccines would have been released. It is the regulator who has got SOPs, standards, protocols, international levels of safety and toxicology, and methods of toxicological experiments, subchronic studies as explained by Dr. Vibha. All these studies, plenty of them, from 60, 70 studies, with so many millions of rupees spent, then only will come to know. And there is no that one single laboratory can determine whether it is safe or not. To the satisfaction of the both public and professionals. How much science I have to tell to the public? Who are these professionals? Is it scientific professionals, or is it somebody who is a chartered accountant or a lawyer? The safety of the product from the point of long-term impact on human health. So whatever I discussed so far, from the European angle, from other angle, this one statement made by the time minister and the government of the day has completely spelled it out. Environment, including rich wealth in existing Brinjal. He was also telling about the biodiversity. As everybody said, that this is one of the black mark in the history of GM crops, which is lingering around again and again when people discuss about Brinjal. I think we should try to erase this particular statement as we go by, and we should completely not mention anything about moratorium. Then only probably people will forget from their mind. So then, but on the other hand, I don't know what type of consensus were there in Bangladesh and what type of issues that have been addressed by our country have been addressed by them. They grew steadily, and now today Brinjal is grown in more than 200,000 hectares, and farmers are happy with 23% profit. And in fact, people are trying to get this Brinjal to India clandestinely and to grow. The farmers are very excited about it. But when it came to mustard, the third crop in our discussion, so we were very cautious about explaining what is the process. Somebody was asking regulatory approvals. This is a simple process of regulatory approvals. And if you see the dates and times, it depends on the applicant, it depends on the regulator, the completion of information. But we have introduced a public comments column that is in purple here, this purple one. And the environmental risk document was kept on the website like in the past, but in a more organized way for GM mustard. And we asked public to wait 30 days, 40 days. Then many people said 40 days is not enough. You put all the dossiers. A dossier has thousands of pages, which was also kept for looking at it, because the applicant said it is all a public funded one. I have no problem any secret, so it can be shown to anybody. So several hundred people visited this. About 3,000 people responded to this one. Then to take a decision on rejection or approval, even after scientific assessment, can work based on the public opinion. You can see what we got is some people opposed with scientific reasons. Many opposed without any scientific reason. Those who oppose with scientific reason are only 5%, 22 of them, and 396 of them. And they said that there is, with all the scientific reason, they said that, okay, I'm talking about the public, which includes all sectors of people, scientists, individuals, and all walks of life. So they all said that, okay, go ahead with this. Therefore, the GEAC, in its session on May 11th, which was the Technology Day in 2014, unanimously approved the GM mustard for cultivation with small conditions. And you can see what we missed is, since we have not taken any decision on that subsequently, what we missed is hypothetically would have been replicating what GE canola has made with Canada. Within 10 years, they have made 100% improvement, would have also gone ahead. But you see the political positions on this. Now, Prime Minister says, we power to transform, because we showed entire GM mustard case when I was in the government. We made a special presentation to Honorable Prime Minister, and some of the slides, in fact, I showed the same of them, same slides. So the current Minister of Health was also telling about a generic statement, not specifically to agriculture. At that time, Niti Aayog also said genetically modified seeds are powerful new technology based on their discussions with scientific community. And the late Environment Minister, in fact, made a statement that all public health related issues have been adequately addressed in the Parliament. The Agriculture Minister at that time said, promote production of crops approved by scientists. He was also going for a scientific consensus. NAS was very careful in saying, moderately high yield, even though it has a moderately high yield, should be released because it can be used by breeders to generate far more heterotic. I have no criticism of this statement, but this word moderately high yield has also made some problem. Many of the scientists who have evaluated, actually the technology was not for yield, it was basically to generate heterotic hybrids. There was no need for mentioning this particular statement. And that has become a case in the court, and the court said it is not giving any yield. And then many scientists, we are talking about scientists, 2 scientists have filed an affidavit against GM mustard because of their own personal problems and also mixed with technical problems supported by some other scientific bodies. So finally, the public said that we'll have a Sarson Ka Satyagraha. We challenged GAC-MOEF to a public scientific debate. Why this squared public scientific debate came? Because that debate was done in Brinjal. We are just carrying on the message which we have given from the top. So it became an issue, and then therefore, what happens? Finally, the GM mustard was pending. Now I was just curiously touching that how far the activism can go in the COVID times. It's very, very amazing to see. I saw a report. The Vandana Shiva is an environmental activist, food sovereignty advocate, who was, as Western economic models and institutions, Vandana has been fabricating a new story that recent coronavirus outbreak was caused by GMO animal feed in China. So I don't know to what extent these things are misinterpreted by people. Now, to end, the technology is going leaps and bounds. Dr. Vene has told about genome editing, the plethora of opportunities that genome editing has got. Regulation started in, as Vibha told, in 1975 onwards, and it is really doing very well with all the best risk assessment capability in smallest of the small countries. But activist agenda is steadily growing. It is growing and growing. As the new technologies comes, the red line, although there is I gave a dashed line because they just keep quiet for some time. At the right time, they hit the technology. Whenever a new document comes, whenever new approval takes place, all this activism starts, whether it is science-based or anti-science-based, it is, I'll tell you later. Now, what is the dilemma then? The dilemma is there is a regulatory due diligence already available. There is a scientific consensus already available. As I have discussed so far, everything is fine. But the political will is very important. Because what I find is the political will that drives both but it is influenced by left thinking and the right wing thinking, and the activists aligning with these, because it's a practical experience I have seen. People aligning with these wings and influencing the government of the day to not to take a decision or take a decision. But on the contrary, if you see the COVID vaccine, the scientific consensus synchronized with the need and potent political will, which led to the key success. Politics and science behind remarkable race for corona vaccine all over the world. PM Modi thrashes politics over COVID-19 vaccines says event by scientist advice. I would say I would be very happy if it said trashes politics over GM crops, says event by scientist advice. If that would have been a statement, would have had a better time for GM crops. In fact, the politics of technology has been there from the day the Department of Biotechnology started as early as 1987, and it is going full circle. So therefore, it is a political will which is important, which has to synchronize with the scientific consensus. And Vibha has shown some websites. I would like to show these websites also. I mean, please participate in these two boxes, opinion box and public consultation. Anybody, because there may be a lot of questions with the regulator. The regulator has to be triggered. If he runs a business on one way, then it is difficult. You have to run the regulator in two ways. You should ask these questions both to GEAC and also RCGM through their websites, that why these things are pending. There can be, for example, if you put a document on the website for public comments, like we did in case of Jim Mustard at that time, there was so many emails, thousands and thousands of emails triggered by all over the world by the activists, but hardly there were any scientific communities or societies or academies of India anytime talking strongly, like the National Science Academy coming out with a report. There was one opportunity for us on Brinjal, but I don't want to comment how good or how bad was that report and its influence was. So there is a need for us to come together to create an academy type document in India and fight for it along with the regulatory due diligence. So there are no two ways. So if there is no dualism in policy. Unless there is a single pathway that we need to harvest double our farm income, and technology is very important, and both conventional, modern, all technologies have to be employed properly to make farmers' income double. It is not just that opposing GM crops we can achieve, or supporting naturalism, natural farming, or supporting conventional farming, or marker-assisted breeding. There is also people confusing between marker-assisted breeding and GM crops. People say, oh, GM crops, there is a controversy, I have shifted to marker-assisted breeding. So all these apprehensions have come over a period of time. The literature on consensus of GM crops from 2016-17 is silent. There is no big literature between 17 and now. I think India has to raise to the occasion in view of genome editing and its opportunities that we have seen today, that come together, have such meetings in a very provocative way, so that we also make our point of scientific consensus from this very land of science. Thank you very much. Thank you.
Thank you, Dr. Sr Rao, former advisor, DBT, and Ministry of Science and Technology, Government of India, for giving a beautiful talk on the topic scientific consensus on the safety of GM crops in India. So we're getting a lot of questions regarding the consensus. So we shortlisted a few questions. One of the questions is, the GMO-based products in the medical and pharma are well accepted by the public, but why not in GM crops?
Pardon?
The GMO-based products in medical and pharma are well accepted by the public, but why not in case of GM crops?
Okay. So this is what I showed actually, because even the mRNA vaccine, which is actually genetically engineered, has accepted globally. So the problem is that agriculture is very complicated. Suppose if you have one pollen with genetically engineered, so there are cross-pollinated crops, there are, issues like, dealing with a huge amount of acreage. And then it is not just one patient. If you vaccinate me, I have to take care of my side effects. So the agriculture is a completely different ballgame. We should not compare. But having said that, the technology is same. And in fact, the technology is so same that genetically engineered products are directly injected in our blood. And we are not questioning that. But while the consumption of GM food, and which is having a very, very minute quantities of a small protein, which has been assessed so well globally with all the science and scientific consensus, we are questioning that. So that is because I explained to you, it is beyond science and regulation in case of agriculture. Agriculture is a very complicated area. Complex regulations, complex farming systems, complex stakeholders, and laws, regulations, politics, they are all based on agriculture. And everybody knows agriculture gives birth to all politicians. So it's all politics. So therefore, it is a very tough area to push any technology so easily.
The next question, what's your opinion about harmonizing scientific consensus, political consensus, and public perception?
Yeah, I told you that, in India, we have not made great efforts to create a document or anything in terms of scientific consensus. We have great academies, and none of course, National Agriculture Academy has come out with some documents, but it is not enough. We have to mobilize all other academies to come together to debate this issue on a longer period, take public consensus on this document that they made. We have to create our own document. How many years we are going to quote the National Academy of USA said like this, Nobel Prize winners said like this. What did we say? When we claim that we are the biggest agriculture scientist network, scientific network, we are the top 3 scientific forces, I think we should create our own consensus document, our own public debate to drive the agriculture needs of our country. At that time only we can bring convergence. Particularly, you cannot, we are always in a mood to please the political lobbies, but we should also inform them that in their mandate, they should also consider new technologies during the election campaign to introduce new campaigns, new technologies. I think we have to take together all the players at one time. We make a serious efforts by state, academy by academy, unless that major mission is not taken up. In fact, Dr. Kaundinya's idea of making these series of webinars, particularly from University of Hyderabad, was basically this only, to again rejuvenate the knowledge and recreate people about the nuances of this technology and how to address, to overcome the gaps that are there.
Thank you. And one more question. What is the current scenario of scientific consensus as well as the economic projections regarding how GM crops are expected to improve Indian economy?
Actually, in case of cotton, we have a lot of evidence by the Cotton Commission of India and then several documents how cotton has contributed after BT cotton was introduced. So there is no, that even the political parties and many other economists, everybody apprised, although some corners of the activists may criticize that one. You see, when you have got millions of farmers adapting a technology, there will be always 10% who will not be following package-up practices. They may not even apply fertilizers. So many times these bad examples are quoted to see the failure of technology. So in terms of the other technologies like BT Brinjal, we have seen Bangladesh getting benefited. But we don't want to learn lessons from a country which is smaller than us. So it is a bit of a prestige issue. This happened actually in one of the discussions. So I think there is a convincing evidence that GM crops have a great value in terms of value addition to the ongoing agriculture practices, agriculture technologies, and it has its own role to play in terms of genetic enhancement of crops and varieties.
Thank you, Dr. Sr Rao, former advisor of DBT, Ministry of Science and Technology, Government of India, for giving a beautiful talk on the scientific consensus on the safety of GM crops in India and for rightly answering the questions raised by the participants. Thank you, Dr. Sr Rao. Now it's the time for this panel discussion. I invite Dr. Ramanjani Gowda, former head Department of Plant Biotechnology, University of Agricultural Sciences, Bangalore, GKVK, to initiate. And he is presently holding as a board member and serving this university as a board member. I invite Dr. Ramanjani Gowda to initiate the panel discussion. He is a well-experienced biotechnologist who initiated the the transgenic research in the University of Agricultural Sciences in the year 1996. I invite Dr. Ramanjani Gowda to go ahead with the panel discussion.
Thank you, Dr. Bannerlal, for the nice introduction. And also I thank the organizers for providing the opportunity to chair this panel discussion. And I invite the three reputed panelists, Dr. Sr Rao, former advisor, DPT New Delhi, Dr. Ahuja, Chief General Manager, BCIL, and Mr. Ram Kundania, Director General, Federation of Seed Industries in India. In fact, and also others who are in the panel. I thank you all for inviting me for this panel discussion, to chair the panel discussion. Before asking the questions to the panelists, I want to make some remarks like recently Mr. Ramesh Chand, Niti Aayog member, said that there is a positive environment for GM crops, and he has also mentioned about the BT cotton, which is grown in India and elsewhere from last 18 years, have no adverse effect. And now the BT Brinjal, after 10 years of moratorium, the government of India has issued the condition that they can go for CFTs, these confined field trials, but they have to take the no objection certificate from the states. But the states are a little bit hesitant to provide the no objection certificates. This issue has to be, in fact, we have to discuss at university levels and state department levels how to overcome this problem of getting NOC from the state governments. In addition to that, there are many problems like growing of illegal BT Brinjal, because BT Brinjal is very much useful for the farmers for the shoot and fruit borer resistance. That's why they are growing illegally. But government of India is strictly controlling this illegal way of growing this GM crops. There are many questions like what are the advantages of this CRISPR versus the other GM crops, and what are its environmental effects or long-term environmental effects of GM crops and human health. So there are many questions. In fact, some of the questions have been addressed by the speakers. With this few remarks, I'll ask only 8 to 10 questions posted by the audience because of the paucity of the time. And now I'll ask the questions related to the speakers. The first question from Sr Rao, consultant, to Dr. Sr Rao regarding what is the need for these GM crops when normal hybrid varieties are high yielding? Dr. Rao, please.
I think, am I heard?
Yes, sir. Yes, sir.
I think, yes, normal hybrids are also yielding. We need GM crops for a value addition in their own way. There is enough background for it. Already our eminent speakers, Dr. Prakash and Dr. Vene has showed what type of small things they can make changes, nutritional changes, the changes for increasing yields, disease resistance, and some of these value-added traits can be easily addressed by the GM crops than the traditional hybrid technologies. In fact, both the GM mustard is an example. They are GM as well as the hybrid production. They go in hand in gloves. So they are not exclusion technologies, they are inclusion technologies. So you should not ask a question against one another. So they have to be included together. Yeah.
Right, sir. Thank you, sir. The other question for Dr. Vibha Ahuja from farmer Miland is asking a question. What is the difference in biosafety regulation of GM crops in India and other countries like USA, Brazil and Argentina? What is the difference of biosafety regulation which is followed in India compared to the regulations which is followed in US, Brazil and Argentina? This is the questions to Dr. Vibha Ahuja.
Is she there?
If not, Dr. Rao can answer this, I think.
It's very, important to know, because the risk assessment for safety or toxicology or environmental safety, the risk assessment principles are same all over the world, except, out of some 3-4 dozens of tests, in some cases, depending upon the biodiversity, case by case, certain tests are exempted. But the regulatory framework is under the law. The law can vary. For example, in case of Brazil, although people say conflict of interest, but in case of Brazil, the Agriculture Ministry does the regulation, not the Environment Ministry. In many countries, Agriculture Ministry does. In some countries, Science and Technology does the regulation, not the Environment Ministry. In our country, we have given all the hands to Environment Ministry. So this irony is there. So that difference is there in the law, and the law who is implementing the law. There is no difference in the risk assessment, except for exemptions depending upon the case.
So, okay, sir. Then a question to Mr. Ram Kondania regarding what is the current state of GM crop release in India, and do they permit release of GM maize, brinjal and rice?
No, I think this was all discussed by all of us, and Dr. Rao also mentioned in quite detail about these crops. I think there have been applications pending for mustard and brinjal. We all know that. On maize and rice, a lot of work has been done. They have reached a certain stage of regulatory data generation. And but like I mentioned in my opening remarks also, that a lot of this work has slowed down in the last 5 years, because people don't see a certainty of approval if they complete the studies. Then why should they complete the study? Why should they invest in generating data? So some, like I mentioned in HT cotton situation, the company has actually withdrawn the application also. So I think apart from regulatory approval, there are also other issues related to pricing, freedom to price the products, and the general difference between states and state to state. I think so these are all conditions which are making it difficult for industry to invest large amounts of money into this, to generate data and bring those applications up to date with the required regulatory approval.
Okay, this is the question asked by Dr. Vasudevan N, Associate Director of Research from India. Anyhow, the next question from Niranjan Murthy, Associate Director for Research USB, to Dr. Vibha Ahuja. If she is not there, Dr. Rao can take this question. How to convince the states to issue NOC for CFTs of GM crops?
Yeah. In fact, the very need, the biosafety, biodiversity, biosecurity, all these things are basically under the Constitution of India have to be dealt by central government. Only the cultivation part, for large scale cultivation, comes under the state list of activities under the Constitution. Unfortunately, because of some incidents in Bihar during the reigns of Dr. Jairam Ramesh, so it was made compulsory to get an ad hoc system of regulation, which is not there in the law. They put a condition that you have to get an OC from the state government. Now, subsequently, many state governments said that, oh, there is something, problem is there, so we will not give any approvals. So, in some of the very prospective states, like in the earlier Gujarat, for example, and then the Rajasthan, no, particularly the Punjab, they made a very nice system. When an application for NOC comes to the Agriculture Minister, Agriculture Secretary, they just tell it to scientific community or Punjab Agriculture University, headed by the Vice Chancellor, a committee consisting of various stakeholders, discuss, and then they see all the documents which have been submitted to the central regulator, and then finally they approve that whether to give an NOC or not. And that is strictly bound by the Agriculture Secretary's office, so which is giving NOCs. But in many states, even in case of Maharashtra, it was headed by not other than one of the famous space scientists actually. He was heading, although he has nothing to do with GM crops. So the seriousness was because of the NOC and the risk, word risk, the committees were formed so strong in the states, some of them misunderstood the whole technology. So that fear complex, fear of unknown has been there. But my advice is that there are already good models which are available in some states, and they can have a small committee of 4 or 5 stakeholders who actually mean business in agriculture, who actually mean business in risk assessment, rather than everybody on the street. So then take a decision. And in otherwise, legally, if you go by rules 1989 or by any law, there is no amendment or there is no gazette notification to get the NOC from the states. It is just a what you call a wag of order, just given like that. You see, there is no gazette notification also. So it is being just imposed. But in many cases now GAC is saying that there is no need for NOC. But yet the state governments are difficult to be approached. So the problem is that the people wanted to solve this problem by designated field trial sites recognized by the state governments in the agriculture universities and their forms. So, or by private sector through a outsourcing CRO activity, like in case of many CROs who do clinical trials. So, but that is pending still. That system is pending. So that is a one good system. Like in Switzerland, also you have a designated field testing site. So there will be the controversy of all the decision making, and the time will be reduced.
Sir, another question for you from Rajshekaran from Bayer. Is a regional manager for Bayer company. What is the prospects of agri-biotech students in India?
Yes. Prospects of agriculture students in India?
Agri-biotech students.
I'm thinking about, I don't know whether there's a BSc agri-biotech.
Whatever biotech, whoever studies biotechnology.
Whoever studies biotechnology. Actually, biotechnology is not GM crops alone.
Yeah.
Biotechnology is a very broad subject. For example, yesterday I saw that biologics particularly are coming back. For example, biological pesticides, biofertilizers, and biological enhancers of yield. There's a huge field of opening up in terms of experimenting biologics. Although investment issues are there, but that is one area. Now, startup in agriculture has started being funded by many people. So even the government is encouraging startups in agriculture. Even there is no unlimited imagination is possible to have a startup in agriculture. So the whole culture of agriculture, entrepreneurship, job, employment is shifting from typical, the system. So any technology person with a good agriculture background and any of the technologies like biotechnology, nanotechnology, or any skills has even field assessments, risk assessment, biosafety. He has a lot of opportunities in entrepreneurship and employment. But he has to specialize. He has to specialize and have a definite skills to exhibit to the industry and others.
Thank you, sir. This question to Ram Kondania regarding, this is a question from Meenal Rathur from IIPR. What is the government opinion for development of transgenic field crops in India by the public institutions?
Well, I think government has always been encouraging public institutions, and a lot of money has been spent on development of different technologies different events in crops by the public institutions. So there is a long list of crops developed by public institutions, and they all have been pending at different stages of regulatory work. And a lot of steam was lost in that work, especially in the last 10 years because of lack of, again, like I said earlier, just like the private industry, even the public institutions are confused about what will happen at the end of the process. So I think there is a certain level of uncertainty about it. But yes, even DBT itself has given a lot of money to public institutions to undertake these studies and this research work. So to answer the question, yes, government has been supporting, and there is a lot of money which is already pumped into this.
Another question to you, sir, regarding what is the future of the cross-pollinated crop if GM crops contaminates the non-GM crops?
Well, I think Dr. Rao is a better person to answer that because whatever I say will be seen as a biased opinion. I think scientists should answer that.
Actually, Dr. Ramajane Gowda,
yes, sir,
know it very well. This is one of the questions hated by me.
Yes, yes.
It's a very non-scientific question.
Okay.
The reason is that, you know, for a pollen to fertilize, it has to synchronize first. It has to be mature enough. It has to be viable. It has to be flown to a flower where nearby. And it has to be compatible. Compatible at the level of stigma, compatible at the level of stamen, compatible at the level of, you know, egg or embryo. So it is a very long process even after that. If there is a viable seed that is going to come, if the viable seed has got a, you know, what you call this, the gene of interest in that one. So several hundred studies have shown this is a very, very rare possibility, and it is a very difficult thing. For example, if you want to hunt somebody as a human being, a man and woman, it's very easy. You can run away. Plants are standing there. So the biology has given, nature has given enough sexually compatible and incompatible mechanisms, and, you know, to protect themselves from any cross-pollination. But in many crops, there is a percentage of cross-pollination possible. But if that is so, the Pusa purple long would not have never existed. It would have become only round, or it would have become whatever the dominant gene is there. So all crop diversity, even the old rice varieties, are all maintaining their own natural identity. So that itself is an evidence that no such thing can happen so easily.
Yeah, I too agree, sir, that because of this, otherwise there would have been new crops if there is such thing, in fact. Yeah. Sir, another question to you, sir, is a question from Gyan Ranjan Rao from Bhubaneswar, head of the Department of Biotechnology. What are the procedure for guidelines for release of gene-edited crops in India? Is there any separate rules and regulations, biosafety regulations?
I think if he has heard about Dr. Vaine's talk,
yes,
the Indian government is also working on the guidelines. Basically, yes, the guidelines are based on the SDN1 and SDN2, SDN3 systems. And the proposals which was there before I left the department, because I was the architect of those guidelines, which I took for about 3 years to really understand the global picture. And it was very nicely made, because under the law, anything that is modified, anything that is where you delete or add, is to be regulated. So in India, all genome edited crops are regulated items. But in that case, what happens to those like SDN1? There is a consensus globally that it does no harm. So therefore, we largely followed the Australian system, whereas SDN1 is left to the institution, the Institutional Biosafety Committee, to take a decentralized decision. And then for SDN2 and 3, rightly said by Dr. Vene Parrott, that there are issues in which regulation will address that step-by-step manner. Not that all that is required for risk assessment, as explained by Dr. Viba, would be needed. They're very simple. You know, you should have a good molecular characterization data. for the regulator to just say, verify, okay, there are no off-target effects, there are no foreign genes like in Brazil or any Latin American countries. I think the problem is that the regulatory guidelines subsequently, there was a proposal to even exempt SDN2. So because of certain things and some subsequent committee, and the whole thing has landed up in Environment Ministry. The Environment Ministry is contemplating that nothing should be decentralized, everything should be centralized. So unfortunately, there is no occasion where this document has been kept on public domain. So therefore, it is the right time that we should demand that whatever the form is, either Environment Ministry or the RCGM, it is a high time that they put in the public domain, all of us comment on it, and then let it be in place. So the basic document is already there. It is ongoing process under review. So we have to get it expedited and by collective action.
Okay. Thank you, sir. Thank you, Dr. Rao and Dr. Ram Kundania for the answering so many questions. But because of the paucity of time, we will send all the questions to the speakers, and the organizers will organize in such a way that to answer all these questions and post it on their website. Thank you.
Thank you, Dr. Ramajani Gowda, for chairing the panel discussion, and many thanks to Dr. Rao, former advisor to DBT, as well as Dr. Ram Kaudanya, DG Federation of Seed Industry of India. Now I request Dr. Anita Peter to lead the sessions. I request Dr. Anita Peter.
Sorry. Thank you, Dr. Benhar.
Please unmute.
Yeah, madam, I have done it. And thank you, Dr. Benhar. And I now request our Dean Agri, Dr. D.L. Savitrama, to give her concluding remarks for this virtual webinar.
Thank you, Dr. Anita. Respected speakers and all the members and all the participants. It was really a pleasure, and it was nice to listen to so many speakers today. They spoke, all of them. To start with, our Vice Chancellor gave about the harmful effects and also the importance, if there are any harmful effects of GM crops. That's one thing which he talked, and he also talked about the need of GM crops, like the Green Revolution, when it came into picture, how we started growing hybrid varieties, like it was of the need of that day, and like GM crops now, because when it is not possible to get any other solutions from other places, other conventional breeding methods, we need to go for these GM crops. And our Director of Agriculture, who has given his wishes, well wishes for the program, that's something nice. And Dr. Ram Kaundinya, Director General, Federation of Seed Industry, he talked about the Brinjal scenario of Brinjal during 2010 and how it was not approved, and also during 2017 about the mustard, GM mustard, he talked about it. And more importantly, he talked about the cost of cultivation, which is increasing even for weeding or for manual labor, which is required. And he talked about the fertilizer usage, and we cannot be giving a lot of fertilizers, and we need to reduce them. And also insect pest management has to be managed well. And the order of the day now, nutritional security is so important. We need to have varieties which are rich in nutrients, like it may be zinc, iron, or protein, or any other things. So in this context, in his talk, he said it's so important to give importance to GM crops, and we need to work on them. Our first speaker, Dr. Vaine Parrott, he talked about the CRISPR-Cas mechanism, and the way he explained it was so well. Even without knowing the science, he could say that it is something like gene editing, or adding the text, or deleting the text or adding or inserting. There is nothing that it's involved about adding any new genes into it. We should not be worried about it, all these things. And the examples what he gave for us to understand in increasing the yield in case of tomato, or when there are 4 genes, how the phenotype is going to be there, and how the 8 genes are there, how it is going to be there, how biomass could be increased. That made it so important. Everyone, I hope all the participants have understood this so thoroughly. And he talked about in different countries, whether in Australia or in Canada or in in different countries, what is the status for CRISPR-Cas mechanism. And for all of them, he said regulatory status review need to determine, and if there is any plant pest potential, potential is there, that should be known, whether it in CRISPR-Cas or anything, it should be known in 6 months. And in conventional breeding, it takes quite a long time to work. Like he gave an example of backcross breeding, and also about mutation breeding and other things, where it's going to take a lot of time to breed varieties. But in case of this CRISPR, you can do in a very short time, and you can give varieties or the crop plants which are the need of the day and for the traits. That was a wonderful talk. Especially he talked how it is going in Japan or in Europe or in France or New Zealand or in Russia. He gave all those things. And Dr. Prakash, who gave on global impact of GMOs on agriculture productivity, he started the most important, the basics of crossbreeding, mutagenesis, polyploidy, protoplast fusion, and transgenic, so that everyone in this participants will understand. This transgenics is something like another way of breeding. And he talked about the BT cotton, which started during 2002, and also the current status, how it is going to be, how it is there in Brinjal or in case of mustard. And he gave the best example, even in Africa, how the GM crops have been introduced. He took an example of cowpea crop, and he gave example in case of Uganda, how for the late blight resistance of potato, this particular GM crops were introduced. And he also mentioned how when you go for conventional breeding methods, even though you get the trait of your interest, many times undesirable traits also would be added, which again you will have to go in for some of the breeding methods to eliminate these traits. That's how these GM crops are going to help us in introducing new traits. He gave examples of how corn yields were increased and virus resistance papaya, which was introduced, which is there in Hawaii. And he also gave an example how in India also we have problem for virus susceptibility in papaya. And chestnuts, eucalyptus, and more importantly, nutritionally important crop, vitamin A rich golden rice. These examples were given. And if we make use of these GM crops in India, we are going to be the more beneficiaries. And he also talked about the need for policies in India, both at central level and also in state level. And we should not miss growing of these GM crops. And some of the questions where they asked about the QTLs, he also gave an example of wheat rust resistance where 7 genes were introduced. Dr. Vibha Ahuja gave on risk assessment, even though she gave very few points, they were so impressive, and about the objectives of risk assessment and biosafety regulations and the process of risk assessment. And what she said is risk is not only in GM crops, even she gave the example in building a dam where engineers are doing, where there is also risk is there. We need to think about the risk which is there in whatever the technology or the science which we are doing it. And she talked about the need of a risk assessment for GM plants, and more importantly, the components of safety assessment of GM crops, what she said, which are so important, which Dr. Rao also emphasized on this, about the molecular characterization, food safety, and environmental risk. These are so important. If all the scientists are going to concentrate on working all these things, there is not going to be any problem. Only thing, biosafety guidelines for genetically engineered crops in India are there, and we'll have to understand them. And in every stage when we are doing the genetically modified plants, from the starting of the research, every stage we do have the guidelines. If we follow these guidelines, there will not be any risk. So, and one more important point, what she mentioned was event-based approvals. It is not that for all the approvals, for all the traits which have been given, for whether it is for BT cotton or for insect resistance or for nutritionally important crops, we need to look into the events which are there. Those events are so important. Based on those events only, the approvals may have to be given. And she talked about the moratorium which was there for mustard and which is there pending with the government, and all that she spoke. And the more important thing, there are 1,150 scientists in India. They're working across 350 institutions. They're working where all of them will be very anxious what exactly is going to happen for the final product which we are going to get. So I think the state and central government need to look into these policies, and will have to be little liberal and talk to the scientists and the scientists, so that everybody, these GM crops can become any other crop varieties or hybrids which we are going to grow. And Dr. Sr Rao, who also was there in the panel discussion, talked about all the scientific consensus on the safety of GM crops in India. And I will not speak more about it because he is also discussed in the panel discussion. And one thing, it was mentioned that when Dr. Modi could get, our Honorable Prime Minister Modi could get the consensus and the approval of the scientists for coronavirus vaccine, why not for agriculture crops, which is the great thing what you have spoken. I think all of us should take this point, and all the scientists and all the politicians and all the activists should consider this, and so that in India we have better future. Technology, and he also mentioned about the technology which is important, whether it is through conventional breeding or the modern methods, or whether it is GM crops or through marker assisted selection. Technology is important. How it is going to come is not important, and we need to accept, and we need to make people aware of all these things. And this is so important, and it was very nice. Dr. Ramanjane Gowda, our honorable board member, and he was ex-head of the department, who has done a lot of work on transgenic crops. He has taken through the panel discussion in a very nice way, and a lot of questions which were raised by many people and have been answered by our panel members. And on the whole, I think our University of Agriculture Sciences has been, we scientists here and across the country, people who are there, have been benefited by knowing the current scenario and the future prospects of GM crops in India. Thank you all of you for giving such wonderful talks and to be involved in panel discussion. Anita?
Thank you, madam. I now invite our head of department, Department of Plant Biotechnology, University of Agricultural Sciences, Bangalore, Dr. R.L. Ravikumar, to propose the vote of thanks.
Thank you, Anita. Good afternoon, everybody. So on behalf of University of Agricultural Sciences, Federation of Seed Industries of India, and Alliance for Agri-Innovation, I thank our Honorable Vice Chancellor for taking time for the inaugural session and giving us an inaugural address. In fact, he is in Delhi to attend some meeting. In between, he took time off for this function, and he has given inaugural address. Thank you very much, sir. I also we greatly appreciate the efforts of Dr. B.Y. Srinivas, Director of Agriculture, and also Ram Kundania who have also like voluntarily participated in the inaugural session and given a talk in the inaugural session. I also especially thank Ram Kundalia for participation also in the panel discussion and helping us to answer a large number of questions which are raised during the course of presentations. And Dr. B.Y. Srinivas also ensured that all the agricultural department staff participated in this event, and also they are all benefited because of participation in this event. I'll thank you very much, sir. And coming to the speakers, see, in fact, we should first apologize to the speakers for approaching them very late, actually. We had a lot of debate whether it has to go online or offline. In fact, we decided this session before COVID. We wanted to have offline, but suddenly COVID was there and we decided to go online, and we had to find some speakers and the good speakers. And when we approached them very late, we had a lot of doubts whether they will really accept this when we approached them late. But we are very fortunate. All the good speakers, when I discuss these things, they are the best possible speakers on these topics in the world, actually. So they have all accepted and made presentations extremely good. Actually, thank you very much, sir, for your acceptance and making the presentations. And our own colleague, and now the present board member, Dr. P.H. Ramanjani Gowda, who is always supportive to us. He is always some sort of a pillar guide to our department. We also thank him for accepting to chair the session and conducting the panel discussion very effectively. So all these things can happen because of the tireless efforts of Dr. Ratna from Alliance for Agriculture Innovation. Okay, and for us, actually, in fact, for us it is a new association, and we were not very sure of this, like how to conduct this, etc. But in spite of all our interference and discussions, etc., Dr. Ratna and his team has conducted this very effectively. Ratna, Dibachia, and Tanmay, they were all very cooperative, and whenever we have discussed anything with them, whenever we wanted some changes in this, till the last minute we were making a lot of changes, and they were all very, very cooperative. Without their tireless efforts, probably it would not have been very successful. Thank you very much, madam. And finally, our own the DL Savitramma, all these things took because of her efforts. Actually, in fact, she initiated all this when Sandhya from Bayer rallies met her. Actually, she has also Anita and her team has taken Savitramma and her team has taken a lot of efforts to conduct this session. And thank you very much, madam, for your efforts. And Dr. Anita Peter, in spite of her lot of problems, I know the problem she has undergone yesterday, actually, okay? And I was not sure whether I would not have participated in this session if I had the same problem, actually. Thank you very much, Anita, for taking your time off in spite of all your troubles, and really appreciate that. Thank you very much. And finally, thank you. Finally, Dr. Nagesh and Benarla for moderating this program. Thank you very much, Dr. Nagesh and Dr. Benner. And I also thank all the participants for participating in the event and getting benefits from this event. Thank you very much, one and all.
Thank you, sir.
Thank you.